slightly late today. Technology has been giving us a run. However, we will go straight into our keynote speech from Stella Chilengat Mte, who is going to be engaging us for the next 30 minutes. Stella is a GIS consultant for the World Food Program in the Emergency Monitoring and Evaluation Department, focusing on the Regional Bureau of Southern and Eastern Africa, supporting humanitarian mapping and disaster risk analysis using Earth observation. She's also a digital Earth champion. So welcome, Stella. Yes, Stella, you can start us off.
Time span, and that is freely available, covering the whole. We provide services that are able to make decision-ready products at a very short time. Thus, the impact of the use of Digital Earth Africa is that one will be able to access data that will enable us to understand the transformation that has been happening across Africa. Number two is the kind of map outputs that will be gotten out of from the hub is that it will be able to be used solutions such as attaining sustainable development goals, in providing solutions to government and stakeholders, and also aspects like agriculture, which is one of the things that I'll be able to present in the next few slides. Another part that's really growing and participating in the Digital Earth Africa Hub is the gender equity, diversity, and social inclusion. That's the JETSI strategy. One of the things that I've appreciated being a participant of the Digital Earth Africa is the diversity that's growing. Different tips, different people, even those that do not know religious passion are part of it in the whole of Africa.
Recording in progress.
And so it's really increasing the capability of women and even those with disabilities participating in the use of Earth observation, understanding how it's used in decision making, understanding the importance of what each and every different country is using Earth observation for, and thus developing new use cases. Another thing that's currently operationalizing is the strategy of integrating JETSI into all decision making and all working partners to identify which joint activities can we work together using Digital Earth Africa. And thus, this is a very key feature that's really growing. And I believe even in the conference that gender equity has also been part of it, which is one of a good commendable point that I'd like to appreciate the conference people that are planning it. And then in my next slide, I'd like to present on a satellite prize that I won on the use of Earth observation in monitoring food security in Kenya, and precisely that's coffee farming. With Digital Earth Africa, I was able to access monitoring of coffee diseases over a long time period using vegetation indices and textural variation. We wanted to see how does coffee farming develop in Kenya, what are the effects, and at what particular point can we advise farmers which are the suitable planting and which are the suitable yield estimation seasons. With Digital Earth Africa, it offered us an opportunity to assess the different agricultural fields of coffee, the location, and also allow the assessment of vegetation phenology over different time periods for a long time series function. And then the Digital Earth Africa also enabled us to conduct a time series analysis. With this, we were able to understand what were the effects of coffee plantation in the previous years and what is currently ongoing, and what advice can we get from the Earth observation to advise the government, the stakeholders who are using coffee farming in Kenya, and also equally the farmers directly. And so using the vegetation indices, we measured the crop leaf area using the vegetation phenology, and we're able to experience the annual variation over the period of years. Then with also use of Digital Earth Africa Hub, especially in the agricultural field monitoring, we're also able to gain the different temporal variation of coffee production. This is a small area in central Kenya which is very famous in coffee farming, and also with that we are able to understand the temporal variation of agriculture in that particular area. There are seasons where farmers were actively planting coffee, and then their season it digressed to different vegetation because of variation of weather and climate, and also because of the livelihood in there and people migrating from one area to another. One of the vegetation indices that we were able to utilize a lot was the NDVI and the enhanced vegetation indexes, which is one of the quite many indices that the platform Digital Earth Africa provides, including with different notebooks for one to be able to participate and use it. This is one of the assessments that we're able to do. If you look, we did a time series function of different farm fields, because this was a data we collected from Central Kenya, and we're able to compare the variation of each farm field in coffee production in between the period of 2018 to the period of 2020. And then, as you can see, every coffee production field varies differently. And this was why was this very important to us? With each coffee production farm, there was a variation of how it is variated in terms of growth and loss of coffee. And this was very key because we were able to understand and go back to understand why did it decrease at a particular season, what were the factors that influence this decrease. And if you see the farms are directly near or related to each other, this was also very important because we were able to compare if one farm reduced and the other continued increasing. Particularly, it may not be the climate change. Maybe it would be the fertilizer the farmer is using, or maybe it's because there was no plantation at that particular season, and maybe the farmer could enhance on us why did they not do a plantation at that particular time. Equally, this information was particularly very important to the agricultural department within the government agency, because now it will help them in planning in terms of fertilization and when to help farmers in doing fertilization. And last but not least, we're also able, as you can see, this was an award that we won. But the most important thing that we came out with this award is how Digital Earth Africa has enabled decision making regarding optimized planting location. Because if you look at this analysis just on my previous slides, places that were very low the whole year, basically because with this we can be able to advise farmers this is not an optimized planting location, and places that were high, that's an optimized planting location. We're also advising the farmers because in areas that had very low fertilization period, they could also explain to us what were the difficulties that they were experiencing then and why they would not be using that particular fertilizer in fertilization. And also we're able also using, because we did a period of between 2018 to 2020, we use it as a forecast on maybe historical and current conditions to predict how the future of coffee farming will be growing and what are the factors they need to be looking into as they look into the future of coffee farming. Also, the use of Digital Earth Africa was quite fairly new at the time we were doing this analysis, but one of the things that we came out with especially as a team, when we're looking at this price challenge, is that it saved us the cost of implementation. Why? Because already the images are ready to be used. They don't require any type of pre-processing or anything. And then also the notebooks are readily available. And for people who are not quite conversant with the hub, then there's a training manual that allows you to understand very well and effectively how to use the digital hub Africa. And so for me, it saved a lot on time, and it made our decision and analysis very fast within the time frame of 1 hour study case. Also, Digital Africa is developing crop mask, and for those who do a lot of agriculture monitoring, this is quite a key success because we want to understand beyond just coffee farming, different types of crops, and in areas that have very many crops or many agricultural types, this crop mask will be very, very important. And then as I finish or conclude in my slides, their analysis ended up at pointing at this type of assessment of crop health. We're able to determine at the start of the season what is the likelihood of the NDVI value, and how does this affect, how do farmers determine what is the optimal point of start of season of planting, and what is the peak of the season in which the crops have yielded very well and need to be harvested, and what is the end of the season. This particular variation is very key. We not only is it available in coffee production, I saw due to various presentations we have on every Wednesday in the hub, we realized even in maize farming and different agricultural practices using the digital hub Africa, one can be able to determine the planting season, the start of the season, the peak of the season, and the end of the season over a time series of period. With this analysis, it can directly affect the farmer because one will be able to guide them on which particular seasons are very important to them. And now you can see with the use of Earth observation how directly it affects the farmer, and indirectly it affects decision making and policy making. And so this is one of the commendable factors. As I finish, there's also one use that's really growing in Digital South Africa, the use of radar data, which is quite important because if you compare the use of radar and compare the use of optical, radar has some more advantages than optical, especially in areas that are clouded. And so this is one of the hub that's growing, and we are learning a lot using it, and it's something that I also encourage everyone to utilize. Yes. So this is the end of my presentation. Thank you so much.
Thank you so much, Stella, for the presentation. I would like to invite questions. Do we have questions from the audience? Or do we have questions online? Oh yes, Professor has a question.
Yeah, thank you very much, Stella, for that beautiful presentation. Mine is a simple one. Could you probably enlighten us how we can get involved with Digital Earth? Is it only the lectures? I see you won an award. When are these competitions advertised? And yeah, how else can we join the Digital Earth family? Thank you very much.
Out to them. I think their details on contact details can be given also through their website. You can just reach out to them at any particular point, especially through the contact details that will be provided. And from that on, you can become a participant because there's a 6 training course that will be given to you for free. And when you go through that training course, we also have classes based on regions. I know there's one in Tanzania and there's one in Kenya. And through this, every particular week, we go through the courses together as a team and understand any difficulty one is experiencing. And from that, you gain to get different use cases that people are using through this hub. And Yes, so that's how you can be able to join. I believe maybe in the conference they'll share the particular contacts of people you can directly contact from the Digital Earth Africa, and they'll be able to enable you to know how to log in. And also their website is going to be free. I think the link will also be posted on about their website and how to contact them. Thank you.
Thank you very much, Stella, for the wonderful presentation. I've particularly registered the importance of gender equality, diversity, and solution strategies, yield estimation. I've also understood better plant growth variability, especially coffee production. And I'm also learning that fertilizers and timing to the season may have more impact than climate change. And all in all, they have a direct and indirect effect on policy and farming. So thank you so much. We appreciate your presentation, and you've gotten us right back on time. And so we are going to have Mr. Kevin Musungu, who is a lecturer in the Department of Geomatics at the Cape Town Peninsula University of Technology in Cape Town, South Africa, who is going to engage us for the next 10 minutes. You're welcome, Mr. Musungu. Is he online? 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 Okay, in the absence of Mr. Kevin Musungu, we will have Tineleb Johans. I hope I've gotten the pronunciation right, who is a consultant with ASIPS International. She's also a researcher with interests in GIS, remote sensing, water resource, climate change, climate impact analysis, and food security. So you're welcome. You can engage us for the next 10 minutes. Thank you. Thank you.
Can you hear me?
Yes, we can.
I'm going to share my screen. Let me know when you got to see it. Hello?
Yes, we can hear you.
May I just go ahead and start?
Yes, please go ahead and.
Good morning, everyone. My name is Tineleb Johans. I'm a researcher and consultant from within the ASIPS team based in Addis Ababa, Ethiopia. Today, I'm going to index for rangeland early warning and monitoring using the Earth observation data, which is applied for Eastern Africa. It is a joint work that we work with for ICPAC and then within the GMS and Africa initiative for rangeland works. I'm going in detail a little bit more about it. My presentation will include the first part with the introduction, followed by the combined drought index input data and methods, the algorithms, the application part, finally the result and how is it applied in the rangeland tool. So as an introduction, as you all know, the occurrence of drought is related to a complicated interaction, such as precipitation, temperature, evapotranspiration, soil moisture, and vegetation, which is to limit some. There are also a lot of impacts that are occurring that are happened for drought impacts. And then we have selected combined drought index because it has almost main variables integrated into one and estimate combined drought index based drought estimation. It's not actually a new index. It's one of the index that are listed in World Meteorology Organization handbook, and then currently it's being applied in Europe, mostly monitored by Joint Research Center, and then NDMC, which is the National Disaster Mitigation Center for Northern America, is also applied. And then it has also partially applied in some of the IGAD regions, which is in Kenya and Somalia by FAO Swalin, which is a particular project that is made for after a great drought that has happened in 2010 and 2011. We have done this work, as I just slightly mentioned in the beginning, developing of a dynamic system for monitoring, predicting rangeland quality quantity for drought status in the Eastern Africa. So CDI inputs are three: the precipitation component, the temperature component, and soil moisture component. In each component, there are two steps that are integrating. So when you say in precipitation component, it considers rainfall deficit and the persistence of dryness, which integrates into precipitation drought index. And then in the temperature component, it also considers two things, which is the temperature excess and then the persistence of high temperature. Finally, it integrates into temperature drought index. And then the soil moisture component also considers soil moisture deficit and persistence of dryness, since this is approximated by NDVI deficit, and finally it's called by vegetation drought index. This is actually the algorithm that we have followed to develop a script. The drought index is the actual average for the interest period, which is the division of long-term mean for that interest period, under square root of actual length of continuous deficit for precipitation and temperature, and then actual excess for temperature, for NDVI. So we have also applied some modifications just to avoid division of zero and then unlimited numbers. So temperature is, as you can see, how we modified each variables, and then for NDVI also precipitation. So finally, we have applied 50% weight for precipitation drought index, and each 25% weight for temperature and vegetation. So as a data source in time step, we have selected our time step from 2001 until 2021, and then the drought is assessed, but it is a 3 monthly time step, and all the CDI in the tool is updated each time all the input variables is available. So for variable rainfall, we have used a TRIPS data set, which is from about 4 kilometer resolution, and temperature from GLDAS, which is 27 kilometer resolution, and for NDVI, spot VGT spatial resolution of 1 kilometer. In general, this is a general schematic representation of the CDI. So as I explained to you, we have used monthly data for all the variables for precipitation, land surface temperature, and NDVI. And then each variable, like precipitation, GLDAS LST, and spot VGT, has been analyzed by pre-processing analysis. And then modification has been done for all the three variables. And then we come up with an index of each variable, which is PDI, TDI, and VDI. And then we apply the weight, and finally we come up with a combined drought index. And then since we have done this for IGAD region, and then our interest was for rangeland, we started by rangeland and then aggregated by admin level 2. So just to see how we applied the CDI application, the CDI has 3 steps: watch, warning level, and also another warning level. A watch is the first application of which indicates a precipitation shortage, and then warning level is reached when the precipitation translates into excess temperature, and finally, the last warning is when precipitation and soil moisture translates into an impact of vegetation. So if it is a value of less than 4, which says an extreme drought is happening, which majority loss of crops are happening, and then if it's greater than 1, which is normal, in that case there would be no drought. So now I'm going to show you some of the results that we have come up for the combined drought index results. The first result that we have seen, actually our main interest was all the way from 2018 on until 2021, but we want to check how the CDI has been resulted for back in 2010, since it was a great event of drought for Eastern Africa. So if you see all the way from January until late of the year, until September, it doesn't indicate any drought on the IGAD region. But then when it comes to October, it translates into mild kinds of drought, and then November also resulted even for Somalia, it translates into moderate kinds of drought. All the way, it also translates into the eastern part of Ethiopia, Somalia, and also Kenya has been affected by the mild drought. You will see how it's also translates into 2011. It's also coming up in January until all the way to April, until after May, it becomes to normal kinds of situation. But then the city captured 2010, 2011 big drought index, the big drought events that has happened in the eastern parts of Africa. So we also analyzed 2018, the first, our recent year application, where for 2018, you may see that the year doesn't actually has much drought, but then particularly in February, it was resulted high kinds of severe kinds of drought. But then it was not elongated; it was just for that particular month. But since we have been communicating to some stakeholders that this was actually happening, but then the CDI has also been captured this event in that particular month. So the next one is all the way from 2018, 19 until 2021. We have produced maps, and this is just the result of 2020. This also has indicating some of the results for CDI, which is happening in the eastern parts of Africa, especially for November, December, which particularly the dry season has been captured for that particular year. So now, since our interest was on rangeland, we have masked out all the way, all the places that are not integrated as a rangeland. So we extract out the parts that are not rangeland. So this is a result of, again, 2020, which is only for rangeland areas. So just for you to see here is first one was it's a combined drought index. So just we have integrating all these 3 major variables for precipitation, temperature, and vegetation, just to see how the spatially distribution of each indexes that are on the left that are also an impact of for CDI. So if you the PDI has a lot of impact for CDI, and then you could actually see that in the spatial distribution that are in each country. Also, TDI and VDI has actually an impact. This also can be seen in the droughts that have an impact for TDI. Finally, this is just to show you, we have produced also a lot, my colleagues have also produced a lot of biomass indexes, biomass applications, and then how is it going to be integrated for rangeland. So it's just some components of rangeland components that are integrated into one tool. This is now controlled by AGPAC, and then each time it's updating when the input variables are available. It has also some forecasts and monitoring, and then there will be an update of each time that the input variables are available. For CDI, right after the TRIFS dataset, GLDAS dataset, and the spot visit is available, it will be updated each time. So when we were producing the CDI, we have been also updating the CDI maps after we download the input variables, which was mostly found from ICPAC GMS website. So now the final, my slide is how we are applying the CDI. As I told you, it's a powerful index to apply for drought by integrating key variables into one. Since it's integrating major drought variables, which is precipitation, temperature, and vegetation, and then real-time assessment of the Eastern Africa drought can be monitored by using the CDI. We have seen how the CDI has a powerful impact for application of drought for Eastern Africa. Yeah, that's my end of my presentation. I thank you very much. I hope I meet the time.
Yes, you did. Thank you so much for the wonderful presentation. I will now invite questions from the audience. Do we have any questions? Yes, Prof. there has a question.
Thanks, Tinebeb, for that beautiful presentation. Mine is a simple question. In light of this information that we have gathered about droughts, what suggestions do you have about mitigating against some of these hazards, if I may call them so? Thank you.
Very nice, very nice. Can you hear me?
Yes, we can hear you.
Hello?
Yes, we can hear you.
Actually, the first thing that for mitigation of drought, knowing where drought is always happening is a key issue. So for us, the first thing that we consider is how are we going to apply for before where the drought is really happening. So real-time assessment of drought for mitigation is a key factor. So the main idea for us is how we see real-time the drought is where is it happening. So we are close to having a mitigation measures in place where, especially for rangeland, which is now biggest ecosystem component.
Okay, thank you. I have a question as well. I saw that the resolutions that you're using differed from between 4 kilometers to 27 kilometers for each of the drought indexes you used. For the indexes you used, that's precipitation, vegetation, and temperature. So how did you resolve that, and also how did you validate your data?
Yeah, the reason that we have for temperature 27 kilometer of GLDAS dataset is because of the advantage of long-term average. We have another product which is about 3 kilometers also from ICPAC. We are looking how the dataset can be integrated into the CDI component, but then it doesn't have a long-term average. So it started for 2015 until now. So we see that TRIFS dataset actually is validated almost for Ethiopia. It's about 96% of all the station dataset. Like it's also having a station data is the trips is forestation. It stands forestation. So for majority of the places that we don't have any complaint in terms of precipitation, which is a major component for CDI. But then for any DBI also, like we have spot rigidity, which is actually a legendary spot, legendary kind of any DBI input. The only concern that we had was for temperature. Couldn't use any other long-term temperature data. But then we are looking now how we are going to transform into the cyclometer, which is currently available for even for IGADRI from IPAC server.
Okay, thank you so much for your presentation. Do we have any questions from online? Okay, thank you so much. We will now invite our next presenter. That is going to be Mr. Paul. Is he around? There's someone holding the presentation on his behalf. Is Kevin on? Do we have Kevin back? Kevin is having an internet challenge. Okay, so we are going to jump to the physical presentations, and we are going to invite Mr. Derek Robert Irumba to engage us for the next 10-15 minutes. Welcome, Mr. Derek.
Good morning. Derek Robert Irumba is my name, and I'm presenting a study with, in conjunction with Professor Anthony Gidudu and Dr. Lydia Mazikayondo. And it's about analyzing spatial temporal susceptibility of wildfire susceptibility in Queen Elizabeth National Park, that is in western Uganda. That is the presentation outline, and I will start with the research background. Wildfires are defined as unwanted fires that happen in grasslands, vast lands, abandoned agriculture fields, and these usually happen in these areas and are uncontrolled in nature. Now, it is been documented that in the sub-Saharan region of Africa, that wildfires are at an increase, and this is because of existence of vast grasslands, but also due to conducive climatic conditions, whereby there is a cyclic occurrence of dry and wet seasons, whereby the dry seasons encourage the drying out of vegetation, making it very flammable, and in the previous wet season, you'll find that the wet season has encouraged the growth of these vegetations. So the recurrence of these cycles bring about conditions that are very good, or that enable thriving of wildfires. And given that wildfires have negative impacts on wildlands, in that they distort habitats or destroy habitats, but also lead to loss of biodiversity, these negative impacts can be very disastrous and thus should be mitigated against. In an effort to curb these wildfires, management of protected areas, such as that of Queen Elizabeth National Park, carry out preventative and also suppression mechanisms, whereby preventative mechanisms are applied before wildfires occur, and these include practices such as controlled early burning, and suppression mechanisms are these that are applied on the onset or during occurrence of wildfires, and these can include fire extinguishing. It should be noted that these practices, the preventative practices such as controlled early burning, have been continuously been applied in the Queen Elizabeth National Park, but however, wildfires have continued to thrive. This is because of their poor application due to lack of information about wildfire-prone areas within the park. Also, the capacity of the park to sustain suppression mechanism is limited due to inadequacy of funds. This is because equipment such as pumper trucks that are used in these approaches are very expensive. So, for effective application of both preventative and fire suppression mechanisms in an effective way, you need to have a knowledge base as prescribed by the Food and Agriculture Organization. So, this research comes in to provide information of fire-prone areas to enable effective application of these mechanisms within the Queen Elizabeth National Park. It should be noted that information of fire-prone areas and also behavior and patterns of wildfires should be updated periodically. But you find that in Queen Elizabeth National Park, studies that have been related to such have been date back as far as 1976 and also the late 2000s, which makes this data very obsolete. Therefore, there is need to update this information, whereby this research comes in. So, for better management of fire-prone areas, as previously discussed, there is need to integrate fire risk assessment, into fire management, and this includes modeling of fire susceptibility to determine areas that are prone to wildfires. As discussed, as stated before, the study area is Queen Elizabeth National Park, which is a protected area in the western part of Uganda, and it covers an area of about 1978 square kilometers, and it is uniquely divided into the northern and southern sectors by a waterway that is called the Kazinga Channel, which connects Lake Edward and Lake George, whereby Lake Edward is on the western side and Lake George is on the eastern side of the study area. The objectives of the study, the first is to study the spatiotemporal variability of wildfire susceptibility in Queen Elizabeth, which is the general objective, with the specific objectives being to characterize the relationship between wildfire conditioning factors and the locations of wildfires within the study area, and the second one to model wildfire susceptibility. Now, you will realize that I use fires and wildfires interchangeably. This is because most fires within the study area are uncontrolled and malicious, and therefore most of them are wildfires. So that is the assumption we are taking. The data sets that were used in this study include satellite data, whereby MODIS and VIRS, that is moderate resolution imaging spectrometer, and the visible infrared radiometer suite that were used to determine wildfire locations or create an inventory for wildfire, 10 topographic factors, then CHAPS rainfall data that was used for rainfall or precipitation data, the Landsat that was used to characterize vegetation using the normalized difference vegetation index. I will discuss this later. And then vector data such as roads, villages, lakes, and rivers for proximity factors. The methodology that was developed for the study is shown in the flowchart. First and foremost, in order to determine wildfire susceptibility, the weights of evidence method, which is a statistical Bayesian form of log linear modeling, was used in this study. And this is used to give a statistical relationship between a factor and an event. The event in this case, which is wildfires. In order to do so, first, an inventory of wildfire locations was created. And as previously stated, this was done using MODIS and VIRS satellite data. And this was acquired in point format. Pre-processing was done on this data including clipping, but also error analysis. Error analysis was done to eliminate locations with errors of commission, that is false detection. And after this, exploratory spatial data analysis was carried out on the data in order to obtain patterns and trends, and after which random subset was carried out. This was done in order to obtain training data and validation data, whereby the training data was 70% and the validation data was 30%. So after which, we go to the wildfire conditioning factors. Now, the wildfire conditioning factors, there is no clear agreement on which factors really determine wildfires from place to place. However, depending on the conditions of the study area and also literature about the study area, you get to determine which factors to consider while carrying out wildfire modeling in a given area. Now, for this case, topographic, climatic, vegetation, and proximity factors were considered. And for topographic, slope, aspect, and altitude were considered. Then for vegetation, the normalized difference vegetation index was used to characterize vegetation. And in regards to climate, precipitation data was used, some of these data sets were applied because of availability. Data sets such as temperature were not considered because of lack of this data within the study area. Then for proximity factors, distance to roads, distance to villages, distance to lakes, and distance to rivers were considered. All this data was pre-processed, various pre-processing was done, and after which multicollinearity diagnostics were carried out. This is because the weights of evidence method that was applied in this study requires for all conditioning factors, which are also the explanatory variables, to not to be correlated. So the multicollinearity diagnostic that was applied was the variance inflation factor, whereby the critical values should be below 5. So after which, using the 70% training data and the wildfire conditioning factors, now the modeling happened. Sorry, the spatial relationships were obtained. I will discuss this more. The spatial relationships are obtained using what they call the weights of contrast, and the significance of the relationship is obtained using the value which is called the final weight. This will be discussed further, from which the first specific objective was obtained. Now, from these, multi-class weighted variables were obtained, which were spatially overlaid numerically to obtain the first model. In the first model, all the wildfire conditioning factors were considered, that is both for MODIS and VIRS. In order to validate the performance of the model, the receiver operating characteristic area under the curve method was used using the 30% validation data. Now, this would give the performance of the model. Now, remember, at first, the first model or the first two models included all the variables. However, in order to determine the performance of each wildfire conditioning factor or its influence on the model, a variation was made using, by omitting one variable at a time, and upon which the receiver operating characteristic was also computed to determine the performance of the model at that point. Now, the best performing model for each set of data set, that is for VIRS and the MODIS derived, was used to obtain the wildfire susceptibility index map, with the best performing used to derive the wildfire susceptibility for the study. Now, from the results, you realize that on the left, the map shows the distribution of wildfires, and MODIS had 534 wildfire locations within a period. The period was running from 2015 to June of 2021, while VIRS had 1585 wildfire locations. This shows that VIRS has more or detected more, and this is expected because VIRS has a higher spatial resolution as compared to MODIS. Now, from both data sets, 60% of the total, approximately, was located in the northern sector, and then 40% within the southern sector. This is also in accordance with previous studies that have observed this, and it is because the northern sector is attributed with very large expanses of grasslands that provide very flammable fuel. On the right-hand side is the graph that shows the monthly distribution of fires, whereby the fires peak twice within a year, that is in two seasons, January to March, and then June to August, with the January to March being the first dry season of the year, and then the June to August being the second dry season of the year. The first dry season of the year was observed to contain more fires as compared to the second dry season of the year. This is because the first dry season is characterized by really higher temperatures as compared to the second season of the year. The higher temperatures lead to drying out of vegetation that makes it more flammable. Also, these seasons correspond to seasons whereby farmers prepare fields for agriculture. In preparation of fields for agriculture, there are practices such as burning of dried out biomass in these fields that can easily result into wildfire occurrences. These are the wildfire conditioning factors. Now, a notable absence in these factors is slope, and from the results, it was discovered that the variability of slope was really poor, and it was giving bad results. So it was eliminated from the analysis. Now, the table shows the spatial relationships. As previously discussed, from the weights of evidence method, the value of C, which is also the weights contrast, determines the spatial relationship, and the W final, which is the final weight, determines the significance of relationships. From those results, what can be seen is that if you have a value of C that is equal to 0, then there is no relationship between a wildfire conditioning factor, category, and occurrence of wildfires. And a positive value of C indicates a positive relationship, while a negative value of C indicates a negative relationship between a wildfire conditioning fire category and the wildfire occurrence. Then the higher values of W final indicate higher significance of relationship as compared to the lower values. Now, this table shows the values for MODIS, and then the next one shows the values for MODIS. You may not necessarily follow the values, but I will give out extracts from the figures. Now, these values show that the MODIS and VIAS relationships that are derived are similar, and this is because both data sets were obtained during this same time frame. So the relationship is the same. VIAS weights final are a bit higher, indicating higher relationships, significance of relationship as compared to MODIS. This is because since VIAS has a higher spatial resolution, it has a higher detection range and a higher variability, implying stronger relationships. Then aspects relationships with fire occurrence indicated very low significance. This is because the study area is located at the equator, and the effect of the sun on different aspects is very low. Then an increase in altitude was inversely associated with the occurrence of wildfires. Generally, low NDVI values were observed. This is because the satellite images or the Landsat images were obtained during the dry season. So this is expected. But also, lower NDVI values were highly related with the occurrence of fires as opposed to the values that you see that are higher than 0.5. Also, increase in mean annual precipitation was observed to be negatively associated with the occurrence of wildfires. Proximity factors provided rather surprising results, with distance to roads showing very low significances of association with wildfires. The reason behind this is that national roads were used instead of feeder and trail roads, and it is known that these feeder and trail roads are more associated with malicious activity that could lead to wildfires. Also, locations very close to water bodies such as lakes were negatively associated with wildfire occurrence. This is because these are associated with activities such as fishing and trade that are not associated with occurrence of wildfires. However, locations that were a bit further were associated with wildfires because these are locations in which farming, beehive, honey keeping is carried out, and these were highly associated with wildfire occurrence. The result from wildfire susceptible modeling indicated that the models were indicated good performance for both MODIS and VIAs, with VIAs showing higher performance than MODIS. Of course, this was previously explained. All models with all variables considered showed the highest performance, indicating that the various factors are responsible for the occurrence of wildfires. Exclusion of variables from models were slightly sensitive to model performance. However, distance to lakes, NDVI, and altitude showed they showed a decline in performance of models, implying that these factors had a higher contribution or influence towards model performance. From the wildfire susceptibility maps that were developed, most fires were located within areas that were highly susceptible, and this is in accordance to the assumption of the weights of evidence model that says that the application of weights evidence model assumes that future wildfire occurrences occur in places with similar conditions that contributed to past events. This is because these occurrences were attributed to existence of vast grasslands that provided for fuel for those fires and also socio-economic activities, as earlier discussed. Wildfire susceptibility maps were categorized into 5 levels, with levels ranging from low up to very high. Now, it can be seen from the graph that 19% of the study area was categorized to be at a very high risk of wildfires, while 20% at high risk, leaving 61% with moderate, low, and very low risk. In conclusion, we can see that the occurrence of fires within the study area is largely seasonally dependent, and this narrows down the time within which wildfires occur within the study area. Also, the conditioning factors, altitude, NDVI, and proximity to lakes, were found to be most influential in determining the occurrence of wildfires. Now, the weights of evidence method provides a good success rate with 70% and 68% for MODIS and VIAs respectively. However, this can be built upon for future studies to enable studying of wildfire occurrences. The results enabled narrowing down of the study area to show the areas that are more prone to wildfire occurrences. Now, from the recommendations, that this study can be upscaled and used to develop early warning systems on the onset of wildfire seasons. Also, highly susceptible areas should be a concern to management, and since they have been narrowed down to about the 20%, the 18% and the 20% that are very highly susceptible, this provides a focus point for management to apply fire prevention and fire suppression. Also, future research should consider inclusion of other factors that are documented to cause wildfires within the study area. And the study should be extended to areas or protected areas with similar fire hazard issues. The main limitation of the weights of evidence method is it provides a similar weight for all wildfire conditioning factors. Therefore, as a recommendation, future studies should consider including or applying it in conjunction with other modeling weighting techniques in an approach that is known as ensemble modeling. Thank you very much.
Thank you very much, Derek, for that good presentation. I will invite questions from the audience. Do we have any questions? Okay, I also don't see questions online, but I have a few of my own. Just about 2-3 questions. What would you recommend as the frequency of modeling fire susceptibility? And then what could it be possible to consider sensitivity analysis, because we are seeing a lot of interaction of variables. Maybe some is being lost to non-linearity. So maybe we would love to look at sensitivity analysis. And then you talked about the difference between fire and wildfire. How were you able to establish malicious fires?
Okay, I will start with the last question. In the preamble to the study area, I hinted that within the study area, majority of wildfires are malicious, and the study took on the assumption that since majority of the fires within the study area are malicious, then all fires that are obtained are considered as wildfires. However, refinement can be made with future studies to provide criteria to differentiate between malicious and wildfires. Then for the part of sensitivity analysis, in this study, specifically, we look at elimination of a wildfire conditioning factor and the performance of the model when that wildfire conditioning factor is applied. However, other sensitivity analysis methods can be applied on the same to get even better results. I would just like a recap on the first question.
The first question was, what would you recommend as the frequency for modeling fire susceptibility, since you indicated that there was a problem with it?
Yes. Various literatures indicate that wildfire susceptibility should be carried out at least every 5 years. This is because human-led factors or influences change from time to time. And therefore, within a 5-year frame, there should at least be a study carried out to update or to build upon the previous studies that have occurred.
Okay, if we indeed have no further questions, thank you so much, Mr. Derek. We'll now, I've been told Mr. Kevin has been able to join us. Is he still online? Okay, so I will welcome Mr. Kevin Musungu, who is a lecturer in the Department of Geomatics at the Cape Peninsula University of Technology in Cape Town, South Africa. You're welcome. Please engage us for the next 10-15 minutes.
Good morning, everyone. Chair, let me begin by apologizing for missing my earlier slots. I had a bit of trouble with putting everything together in the presentation. Are you able to see my slides? All right, my name is Kevin Musungu. As the chair has mentioned, I'm from CPUT, which is in Cape Town, and I'll be presenting today a work in progress, one of our research topics being done by our students. Our students undertake what we call industry-based learning, so they are partnered with people in industry, and they must tackle a particular problem. So this is one of the problems they are looking at. It's downy mildew, and I'll just speak briefly about that. So the topic is to identify downy mildew using remote sensing. And for this presentation, I'll be talking about the use of a multispectral drone. So the order of my presentation, I'll begin by talking about what downy mildew is and how it affects the vineyards. I'll then talk about our case study area, the data and methods that were used, then briefly look at the results and the ongoing work as we prepare for actual publication. So what is downy mildew? Downy mildew is a particular disease that can be rampant sometimes, especially around the winter seasons in vineyards. And it can be very, very devastating because it can wipe out entire vineyards. The way it spreads is that it begins with blots on the leaves, and then it creates a fungal growth on the stalks of the vines, actually hold the grapes. And over time, they get an ashy appearance, and subsequently, they fall off to the ground. So the stalks become too weak to carry the grapes, and then the grapes fall off onto the ground, and that can create a significant loss in the viticulture industry. So it's a matter of interest. We were asked to investigate the potential for using remote sensing by a farming community, and we went to this particular site, which I'll come to in the forthcoming slides, which had actually been afflicted by downy mildew. So because of the losses associated with this, it was imperative that we actually did this mapping process. Now, there have been a series of publications that have looked at downy mildew using different approaches, some mapping the leaves, others with handheld spectrometry, machine learning algorithms, etc. One of the issues you will notice with downy mildew, if I go back to the previous slide, is that a lot of the blotting starts from underneath the leaf. So it's not easy to detect very early by satellite if it's at a very coarse resolution. So we're building on this ongoing research with remote sensing in viticulture. And other studies, more recently, but let's take a snapshot, have also looked at the use of indices on how they can improve the quality of classifications, along with machine learning algorithms, which is what is commonly used in present-day remote sensing. Our study area is located in Wellington. It's a city in the outskirts of Cape Town. It's generally a farming environment, so you'll see from this snapshot of Google Maps that it's surrounded by a series of vineyards. Our study site is actually to the northwest of the Wellington city or town, and that is where we did our actual mapping. The methods we use, the methodology involved using a multispectral drone. So we had a Phantom 4 drone Pro, which was carrying its camera, the normal payload, and from that we're able to survey and map in just red, green, and blue, normal photography. Along with that drone, we also had a MicaSense multispectral camera, which also records red edge and near infrared. So we have, when you use that, you have the opportunity to either capture all 5 bands on the multispectral camera, or what we did in our case is we captured the normal red, green, blue with the onboard camera on the Phantom 4, and then we only captured the near infrared red and green on the multispectral camera because the Phantom 4 has a high resolution in RGB. Having done that, the way we process this, and I'll come to that again in forthcoming slides in Pix4D, is because the drone, the camera has a sensor at the top, one is able to calibrate the reflectance at the time of day, and then transform the images into actual reflectance prior to creating indices and orthomosaics for each of the bands separately. Once you have each of those bands, you can then create your composites, indices, and proceed with classification. What's important to note here is that unlike satellites, where there are a series of predetermined methods for calibrating. Most of these cameras rely on using reflectance marks, which are then used to calibrate after the flight in conjunction with the sensor on the cameras. In addition to that, although the camera has an onboard GPS, it's generally accurate about 2 meters or so. So we surveyed a series of ground control points. If you look at the left-hand map, so what you're looking at there with the green arrows are the ground control points around the actual farm area, and that bottom area. These other parts had already been harvested. On the right-hand side, you will see we also did a series of ground truthing surveys with GPS, with RTK, and that was used to determine which areas were actually still having the disease visible and which areas were actually having healthy vegetation. With Pix 4D software, we're able to generate orthomosaics and digital surface models. We didn't use the surface models in this case because it was one piece of vegetation that were all just a vineyard, but we came up with an orthomosaic which with a resolution of 6 centimeters per pixel. We also computed several indices, including EVI, indices, NDI, NDVI, etc. And a DTM was also produced, which one can use if they wanted to extract to discriminate weeds, for instance, from the actual vegetation. But in this case, we aren't concerned with that. This was done through Pix4D. Having gotten the actual bands, the orthomosaics for each band separately, as well as the indices, we then did a series of machine learning classifiers, including the Gaussian mixture model, nearest neighbor, random forest, support vector machines, artificial neural networks, and the naive Bayes. They didn't all perform well. In fact, the artificial neural networks and naive Bayes were eventually discarded. And as you'll see in the forthcoming results, we focus primarily on the other 4 classifiers. These were just a snapshot showing the outcomes of the orthomosaics for the separate bands, multispectral, that being the near infrared, the red edge, and the red. We also had the RGB, high resolution, 6 centimeter images, which one could then use to extract extra samples prior to classification. So although we had several points surveyed by GPS, we were able to then, looking at this photography overlaid over each other, extract additional samples for classification. It was split in a 75% for classification, 25% for validation. And these are the maps that were extracted for the 4 base performing classifiers. They have very slight differences to each other, but what they all show is that the northern portions of the property were most affected by downy mildew. The lower half of the farm was barely affected. In fact, on inspection, there were very few plants at the time of this capture that had been affected by downy mildew. And normally, once they pick this up, they're able to treat the soils and clear out whichever vegetation needs to be removed to avoid the spread of the downy mildew. The empirical results of the classification, you'll see that from the training and the actual classification, the random forest and support vector machines performed the best for both just the bands themselves and the bands with indices. So when you look at these graphs, what you're looking at there, that is random forest on its own, just on the bands, the 3 bands, and then random forest with indices, added to them. So there was an improvement from just having the bands on their own actually including the indices in it all through. However, the poorest performers were naive Bayes and the artificial neural networks. So what are we doing now? So currently we are investigating further into the application of the indices. So although one is able to have a high detail of indices within using UAVs, it is extremely cumbersome to keep on capturing this data using UAVs. So we'd like to upscale nanosats. And what our students are currently doing is investigating which indices, texture models, etc., can be utilized for long-term monitoring of these farms using nanosats. And in particular, we're investigating the use of Planet Labs. Thank you very much. I don't know if there are any questions. Thank you.
Thank you so much for that presentation and the wine. We appreciate. Do we have any comments from the audience? Okay, I'm also not observing questions online, but I have a few of my own. Mr. Kevin, do you think if the disease actually starts from below the leaf, the camera angle and the flight pattern would have had an influence on generating better results or different results? Otherwise, how did you solve the issue of the disease coming from below the leaf?
Mr. Evan, could you repeat the question? It was muted. Could you repeat the question? It was muted.
Okay. Okay, I hope you're able to hear me now. I'm saying that since the disease starts from below the leaf, how were you able to resolve that? Then two, would the camera angle and the flight pattern have given different results?
We can only pick it up at a certain stage of development. So, if I can just go back. One of the bigger problems with this downy mildew is that the grapes sit under the leaves, and that's where most of the evidence is with it. However, you'll see from these images here that although the blotting starts from beneath the leaf, it becomes evident as well at the top of the leaf. So one is able to pick this up from above, above the canopy. In terms of the flight patterns, certainly, if one, in order to map the entire farm, one must extend the flight patterns beyond the actual boundaries of the farm, or that area of interest anyway. So then the overlap will be sufficient for one to actually observe whatever they need to observe within this site. In terms of the direction, it wouldn't have mattered so much in this case because we're flying at about 100 meters above the property. But it could become difficult if one wanted to look at it over time. So if one wanted to do a change detection, it becomes very difficult with UAVs because at 6 centimeter resolution, slight movements, even of wind on the leaves, can give a false impression of change. So that could be the only impact that perhaps a flight pattern could have an implication on it.
Thank you, Mr. Kevin, for the wonderful presentation. We've registered a lot we can do with the UAV, especially the modifications of the cameras. I would like now to slot in one more presentation before we go to our break, and that's Mr. Edward, who is a lecturer in the Department of Geomatics at Swene University of Technology in South Africa. You're welcome, Mr. Edward. If you can engage us for the next 10 minutes.
Thank you. Loading my PowerPoint now.
Yes, Mr. Edward, please go ahead.
Thank you and good morning. My name is Edward Kurwakumire from Tshwane University of Technology. My talk will be on the design of a disaster management course using a teaching pedagogy approach. I think for those who followed my presentation yesterday, I had a talk regarding the natural disasters which we are continuing to face, and we are experiencing them quite more often with increasing frequency. So disaster response, disaster preparedness is something which nations really need to engage in, so that as of when there are disasters, it will be possible to possibly mitigate them in a much better way. So we need to develop strategies, and the strategies need to be designed, tested. But then for us to effectively do this, there is need for the appropriate capacity building to be done. So if we look at our current situation with in the geomatics domain, you see that normally we talk of disaster management, normally as an application. It could be discussed as an application of GIS, as an application of remote sensing, but sometimes we are not actually having a disaster management course within the curriculum. So our thought was that if we could have a component of disaster management within our geomatics courses, it could equip students with the capability to actually participate more effectively in the disaster management arena. So there's a need to develop either short learning programs for professionals in industry or to develop modules which we can fit within our normal geomatics curriculums. But then again, not everyone is equipped with the know-how for course development, because normally with teaching professionals, we are not having teaching qualifications as well. So while we may have subject experts who know about the content to be covered, there are some aspects from teaching practice, which is referred to as teaching pedagogy, which are involved in course design, which also needs to be considered. And from there, you would find that course design is actually a complex process, and normally it benefits if it is done in a collaborative way. So the intent of this study, when we complete, is to design a 12 credit module, which means 120 notional hours for disaster management, but something which we can fit within a geomatics program. And then we are hoping that from the module framework which we will provide, this can add value to other practitioners in different institutions who would want to develop similar courses, or when you are upgrading your courses, maybe to add new content or to meet some new needs. But then why should we apply the pedagogical approach? This could be for a different set of reasons, because sometimes you see that there can be a course which you found at a university, maybe it's a GIS course, but when you look at the documentation, it is not even clear what competencies students are supposed to attain, or maybe the outcomes of the course, the aims themselves are not even clear, or maybe even the content itself is not even clear. So maybe the course seems to be just put somewhere. It is not seemingly aligned to other courses within the degree program. So we need our courses to be structured in a way that is promotes effective teaching and learning. So by teaching and learning, we are saying that as the teacher teaches, the students must also learn, and coupled or to go with that, there should be assessments, and then there should be feedback as well. So how then do we position the module? So here we are looking at within the surveying, the GIS, remote sensing, photogrammetry, and other courses which are within the program. Where is this module fitting? What prior knowledge should be there to position it, and within the current modules, are there modules providing this knowledge, or should some prior knowledge be incorporated in some previous modules so that when students actually participate in the course, they will have the adequate prior knowledge available? Then how then is this module to be taught? So there are several learning theories which are available, which you can choose from. I only mentioned two. One is constructivism, the other one is sociocultural. So in constructivism, we are saying that the learning which is done is student-centered. So we construct knowledge from what the students already know. So we start by an activity which students do, and from there, the lecturer facilitates and build on that knowledge. So students are more in control of the activities or the classroom tasks. In social cultural, we are just looking at the different backgrounds which students bring in, their different knowledge, and we see how we can accommodate the different kind of students so that each and every student can actively learn and benefit from the teaching process. Then how then will the disaster management course be conducted? Will it be project-based? Will it be case study-based? Is it delivered in an online manner, in a contact manner, in a multimodal manner? What technology do we need to impart the knowledge? What hardware and software is needed? What learning management system, is there a learning management system to be used? And to what extent would it be used? Which other resources do we need? Do we have the training staff available? Do you have the technicians, the tutors available? What data sets would we need? What prescribed books would we need? So these are all aspects which need to be looked at when we are doing the course design. Then what teaching approach are we looking at? Will it be active learning? Will it be teacher-centered? Even though currently we are promoting active learning because it is student-centered, it is collaborative, and there's also a concept which is being talked about, which is called the flipped classroom, in which students are more participating, and again, the lecturer is more like a facilitator within the class activities. So for example, this is the traditional lecture room whereby students are in a lecture theater and we'll have the lecturer in the front talking to the students, imparting all the knowledge. And you still see this scenario still happening nowadays, especially for programs which will be having many students. But what we want to move towards is this scenario whereby we group students and even the seating arrangements are different, and students, they work on tasks, and we have maybe one member from each group presenting, and they ask each other questions, they share the knowledge, the lecturer intervenes, and in this way, students are able to exchange ideas, and we can shuffle these groups as you seem necessary so that all the students, they get a chance to interact with each other. So in this way, you promote learning in different ways. So when you consider this, you will find the way you would then design the course, it will be following this approach which you actually use for the actual teaching. So designing a course is much more than just the learning units and the learning outcomes. If you design it coming from an angle again, whereby how are you going to be actually doing the teaching, it will really change and add value to what the content of the booklets which you provide will be having. So you need to design a module descriptor, and in here we'll have the purpose of the module. So what is the purpose of the module? We'll have the competencies which students should be able to have at the end of the course. So here we'll be saying students should be able to do A, B, C, and D. And then we need to distribute the credits across different activities in the module. So if it's a 12 credit course, it is a semester course, but now we need to say the 120 hours, how are they going to be spent within this module? And this should be stipulated in the module descriptor. Then we go to the learning units of the module. And there we are saying what knowledge gaps are available and how can we use those gaps to design our learning units. Then also what exit level competencies should be there. And from those exit level competencies, we then also design our units. What material is needed for the students to learn or to support their learning or to support their practical work. and these are the prescribed and recommended books. Then we go to the learning outcomes of the module. So whereby we also look at how are we going to assess the students, what activities will be done by the lecturers, what activities will be done by the students, then what formative assessments will be there per unit, what summative assessments will also be there per unit. Then the credit allocation, we need to look at what hours are allocated to teaching, what hours are there for tutorials, for practical work, for the assessments, for self-study, for research work. Sometimes you need to put in a work integrated learning component whereby students actually maybe visit an organization for a week and learn from there. And then from there, maybe they design a portfolio of evidence. Then again, as you are designing your outcomes, and also depending on where the course is positioned, where exactly will it fit? So for example, we have the Bloom's taxonomy, which you can use to design your outcomes and assessment criteria. So at the bottom, you see there is remember, then understand, apply, and at the top there is create. So if it's remember, it is like the entry level content which normally first years are examined on. But like if this is an exit level course, we expect students to be analyzing, to be evaluating, to be creating. So this framework can assist you in developing outcomes which are suitable for the level of the course. And to add this, the framework comes with a number of verbs. This list is not exhaustive, but it has got some of the verbs. So you see that, for example, if we are at the bottom part, which is remember, we are just testing the knowledge. So it's defining, identifying, describing, explaining, and so on. But if we look at the highest level, which is create, we're asking students to define, to design, to modify, to develop, to rewrite, to critique, among other things. So you see that the way in which you will assess students is now at a higher level. So this help us to make sure that we position the course correctly and the content which is there is fitting with the level which we have placed it. And it is good practice to do this in a collaborative way with using a team of experts. And normally you would find that an examination from professionals which are outside the field would bring good feedback, which you can actually use. So to just demonstrate how you would conduct this collaboratively, there is a platform which is called Mural, which you can use collaboratively with people. You can work together in different locations. So you can plan your module using this. So for example, this is for one of my courses which I teach is adjustment of errors or adjustment computations. So what we did for this course was to say the first week we need to orient students. So since students are new to the course, firstly we do what is called acquisition. So it will be me, the teacher, who's starting. So I will tell them what the course is about, and I will have some videos for them to actually see what the course is about. Then I engage the students in a discussion to also find out if they have got questions, what they want to know. Then I talk again, and maybe I give them some work to do in preparation for the next class. Then I'll have my units for the first 4 weeks. And in these 4 weeks, it will be me, the teacher, who will be starting by a bit of content. Then we engage in discussion. Then I put students in groups so that they can collaborate. I also give them work to practice. And at the end of the lesson, I give them work to go and do at home, to go investigate, so that when we come back to class next time, we'll now start by discussion. So instead of me being in front of the class, I'm starting by saying, okay, groups, can someone from one person from the groups present something? And then I come in as the lecturer in acquisition, and then we do more collaborations. I give students practice work, and we do investigation. Then later on, you find that in the course, there is investigation, there's discussion, there is collaboration, there is production. So students are now able to do a project, and they continue practicing. So in this last block, my involvement as a lecturer is now like only consultation. So students are working much more independent. So even this design, you're actually able to integrate it within how the actual course will be conducted. So these are aspects from teaching practice which we can apply in the way in which we design our courses. Then I will come to my conclusions. So I think it is imperative for us to build capacity in disaster management so that we can have the manpower or the main resources to participate. And to assist in that, I think we need to develop the courses which are integrated in the geomatics discipline for disaster management. And that will also make sure that we increase the utilization of spatial data in disaster management. And again, the course design really benefits from application of teaching pedagogy practice. And with this, I come to the end of my presentation. Thank you.
Thank you so much, Edward. That was highly informative of how to deliver content on disaster management. Do we have any questions from the audience? Do we have any online? Okay, there are no questions, just appreciation for the knowledge delivery concerning...
There is a question here.
Okay, there's a question.
Okay, yeah, thank you, Edward, for the presentation. So my name is Brian Makabai from Makerere. So my maybe comment to see what you perceive of it. Normally, when you are working in the disaster domain, you find that the multi-dimension understanding is limited. So you'll find that every professional understands from their side, and also the students who are doing research in disaster, they don't perceive the problem well because of their myopic understanding from where they are coming from. So don't you think we should have a course which is multidimensional than targeting only, for example, geomatics? I'll give you an example. We have engineering solutions, for example, to a disaster. And in the geomatics, we are more of predicting and doing early warning. And then you also have the social aspect. So if you have a course that is multidimensional, you'll find that the tackling of the disasters will actually be more effective than putting emphasis on designing a course that is so specific, for example, in geomatics, where you are most likely going to be dwelling in forecasting and early warning, and yet early warning is informed by also the other parts surrounding the disasters. Thank you.
Thank you for the question. My point of view was coming from we have professionals who have got a role to play. So I think within geomatics we have got a specific our specific roles. So apart from early warning systems and so on, when the disaster response is actually being done, we have a role of, for example, gathering the data, processing the data, and conveying some information which can be used in real time during the field. So this would need students like who have done a GIS remote sensing. So if we take this course and put it in another field, it may be challenging. It may be challenging for those students because they do not have the prior knowledge which will be targeted from our end. But I understand your point of view that if it was to be made multidimensional, it will be more value. But I think the prior knowledge is what will be the problem with doing that approach. That is my thought on that.
Okay, thank you, Mr. Edward, for that presentation. I think we can now go for our break. We can go for a break of about 10-15 minutes, and we should be back here at 11:15 so that we can fast track the other presentations. Thank you.
There's another question.
Excuse me, I'm asking for guidance. Haven't we closed, or I can just make a comment on the previous presenter?
Maybe you can make a comment. Please guide.
Yes, thank you very much, and thank you, the presenter. Joel Kitutu is my name. My question is around the approach, because what has been presented looks to me like the traditional approach of teaching, especially in technical institutions. So my question is, what's new? Looking at the changing trends, we are in a world that has changed from how it was like 5 years, 10 years ago. If we are employing this same approach, what's the new ingredient that is being presented? That's what I would like to see. Thank you.
Okay, that's more of a question than a comment. I don't know if Edward is still there. Edward, if you're there, you can make a comment on that so we can close.
Yes, I'm still there. Let me. Okay, so what you do with this approach, let's say as an example, with every unit, okay, the traditional approach was that the teacher comes in and they lecture. But now you can have a lecture video which you give to the students before the lecture, so that when you come into class, what you can do by the only way you can add value to the students is not by showing them a calculation, but by explaining, but handling their questions, for example. Then with each activity which you need to do, we need to identify what technology can you use. So because there are different softwares and so on and so on. And then we teach them how to use the different softwares. So for example, with adjustment computations, they do manual calculations with my class, but they also do automation with Python and machine learning as well. So that we know that this concepts are basic in surveying, but now we need to use technology so that they get the maximum value, or they know how to utilize technology to better the approaches. So I think it is a matter of perception so like what this enriches is actually how you actually design the module. I don't know if I have answered the question well.
Yes, he seems to have big clarity on that. Yes, we can now go for the break and be back in 10, 15 minutes. We'll begin at exactly 20 past 11. Welcome back from the short break. We will now go into our second session of the day, and we'll have a presentation from Mr. Kamoga. Mr. Kamoga, you can engage us for the next 10 minutes.
If you have something, a video that is geotagged, it can be VGI as well. You can have image VGI, for example, Instagram and the rest. But our major concern here is map VGI, which is basically concentrating on collection of points, lines, and polygons. And the main initiatives under map VGI can have OpenStreetMap with Mapia, My Google Maps, and the rest. But among all those ones I mentioned, OpenStreetMap is the most successful among all those, based on the number of features, stores, and number of registered users. So its success, even in Uganda have been able to tap on this success whereby you have seen most organizations in Uganda and individuals mapping different areas and different major cities in Uganda. For example, Jinja, Kampala, most of them have been mapped using OpenStreetMap. However, like I've told you how this data is collected, people or citizens usually collect this data, seldom have a GIS background. And the main issue that has been risen by researchers and most national mapping agencies all over the world is the quality of this data. OpenStreetMap is here in Uganda, and people are using it, and it can also be a viable source of, alternative source of geographical information, but its quality has not been yet comprehensively assessed. However, there are previous researches that have been carried out in Uganda about the quality of OpenStreetMap, and that includes one that was done in this department by Owen and Professor Gidudu. They assess the accuracy of linear data sets of OpenStreetMap. However, there's more that we have to do that can be done as far as this quality assessment is concerned. Whereby, if you are to adopt VGI or OpenStreetMap as an alternative source of data in Uganda or in our work that we do, this quality is supposed to be comprehensively assessed. So this will lead us to the problem. Like I've said, OpenStreetMap is here, the data is here, so what we have to do is to assess comprehensively the accuracy of this data as compared to our data sets that we have here, especially the ones that are provided by our Department of Surveys and Mapping, which is the National Mapping Agency in Uganda. So we see that, for example, the data set that we have, maybe the topographic data sets, are out of date, and never know. If you could use this OpenStreetMap as an alternative source of data, the better. So the issue here is to assess the accuracy and see whether it can be viable and incorporate OpenStreetMap in our data sets and easily use it as an alternative source of data sets. So majorly what this project or this research is looking at, we want to evaluate the accuracy of the building layer of OpenStreetMap in Jinja district. This is what we majorly did. That's our main objective. And to achieve that, we developed some specific objectives. Number one was to determine the homologous buildings between the OpenStreetMap dataset and then our reference dataset. This will be like majorly to get the matching buildings between the two datasets so you can carry out assessment in number two. So that will be to determine the accuracy of the OSM buildings relative to our topographic datasets in Uganda. And we chose 4 quality parameters, that is the position, completeness, attribute, and shape. So when we assess these parameters, they will give us an indication of the fitness for use of this OpenStreetMap, and we can come up with data as in a generalized statement about the quality of OSM in Uganda. So this was our study area, and reason why we chose Jinja, we want to look at how OpenStreetMap varies from rural areas, from maybe urban through peri-urban to rural areas, and Jinja can provide such a platform because it has urban areas, has rural areas, and then the peri-urban. So, to achieve our objectives, we adopted this methodology, and the outline of the methodology is as illustrated there. First one was to select test areas within Jinja where you can conduct our survey, and it's not clear, but we selected 3 test areas. First one is around Jinja City, the central division, representing the urban. Then another in the periphery, Budondo, representing the peri-urban, and then Buyengo, representing the rural areas. So these ones are selected purposively based on the population density and then settlement patterns within. So these ones qualified for those urban, peri-urban, and then the rural. So number 2, we went on and created data sets within these test areas. And majorly here, like we are comparing OpenStreetMap building layer and then the building layer of our data sets here in Uganda, provided by the Department of Surveys and Mapping. So we collected OpenStreetMap from that portal, and then the ortho photos. Unfortunately, we didn't have current vector data sets of Ginger, so we collected ortho photos that were later digitized and extracted the vector data set. Even the population data came in top in section of test areas. So the data that was collected, this is basically a genetic comparison of the data sets. So if you can look at that, that's basically a genetic vision or view of the OpenStreetMap building layer and then the reference data set. So blue representing OpenStreetMap and then red representing our reference data sets. And this is basically a genetic comparison of the data that was collected. So after collecting that data, we had to carry out some pre-processing, data cleaning in particular. And the first thing we carried out here is a coordinate transformation. Like we are comparing OpenStreetMap and then our reference data sets. So OpenStreetMap comes in a geographical coordinate system. So we had to convert that one to match our current geographical system. Our coordinate system, which is UTM 36 North, and then ARC 1960. So that they can be matching. So for us to be able to compare the two, that would be in the unified coordinate system or reference system. Then, like I said, we extracted data sets from the ortho photos, and then we also carried out topographic checks, these being vector data sets. Then, after this data pre-processing, we went on and say the processing. And from the first objective, the rationale behind that first objective was to determine the matching buildings between the two data sets, because all the assessment was carried out on corresponding or homologous buildings between the two data sets. So the aim here was to find which building corresponds to which building in the data sets. And we did this using the multi-criteria matching algorithm, whereby this one has 2 steps. We have to first determine the candidate polygons or buildings by the overlap method. Then those ones that satisfy the criteria that the overlap is purely greater than or equal to 15 passed, and the rest were rejected. Then those ones that were passed were further analyzed based on the shape, and those ones that passed were our homologous buildings. So here we achieved our first objective. Then to achieve our second objective of quality assessment, remember we had position accuracy assessment, which we did using the centroid method, whereby in this one, we could, using that formula, we can get the distance between the two centroids of the reference building and then the OSM building. So that Euclidean distance between the two centroids gave us an indication of the positional accuracy. Then for completeness, we got the summation of the centroids in the OSM over, or the percentage of the OSM out of the reference. So that one gave us an indication of the completeness of the data set. Then the attribute, we had 2 assessments in the attribute. We had completeness assessment and then the accuracy. So we had to find out how well have the attributes been mapped and the accuracy of those attributes using that formula, and for accuracy using the misclassification matrix. So for the shape, we did area ratio assessment and then compactness assessment and then the elongation assessment using such algorithms, and we are able to get this. So for the first one, the building matching algorithms gave us cardinalities. We got a number of reference buildings that are matched with a corresponding OSM building. And this was our main area of interest, the one-to-one cardinality. And then we're also able to get those cardinalities that could help us get an indication of the area due to commission and then omission. So the results from the building matching can show us the contribution patterns of different individuals. For example, in here, we can see that in Central, we have more contributors as compared to the rural area in Wiengo. So, implying that OSM is still lacking in the rural areas, even before you go to the further analysis of the completeness. So, for the position analysis, that map shows the spatial variation of the position accuracy from the urban area through peri-urban and then the rural. And from that map and this graph, you can see that the accuracy, or the positional accuracy of all the OSM building in all the 3 areas is nearly constant, and is around 4 meters. And why is it constant? This is basically due to the nature of the collection. Most of these images, or these buildings, are digitized. So this offset, why is it constant? This is purely a difference between the orthophoto layer and the image that was digitized. That's why the accuracy is constant all through there. Then completeness, like we have seen in the building matching, even the completeness assessment also confirms that completeness decreases as you move away from the urban areas to the rural areas. So actually this one rhymes with the previous research about OSM, also happened here in Uganda, also in Jinja, that the completeness of OSM reduces as you move away from the urban areas, as shown in these statistics that we have here. Then for the shape, generally, because of time, the general shape assessment of OSM relative to the reference data set that we have here, shape compares well from the statistics that most of the shape parameters are above 90%. The comparison is okay. But as you can observe from here, the architectural detail of the OSM is still lacking, as you can see here. And this was further assessed to confirm this hypothesis by comparing the area and the perimeter of the two, and was found out that the perimeter of reference buildings was higher than that of the OSM, and the area was smaller, reverse-wise. So, confirming this hypothesis of the actual ratio between the two. Then the attribute, generally also because of time, attribute is still lacking. Most of the data sets don't have attributes in OSM, and we can see that only 1.17% of the buildings that we assessed have attributes. But when we further assess the attributes that we picked, we found out that the attribute accuracy is actually like 90%, but the attribute completeness is generally still lacking. In conclusion, we can see that the building matching helps us to, and also helps us to analyze the contribution patterns of OSM. And generally, like we have said, as in the positional accuracy is still constant all through because of the misalignment of the imagery. But for further research, if you could adopt a better algorithm for future matching, because it was one of the main source of errors in this research, because this one was, if you can have a better algorithm that can identify multiple cardinalities, that can help in our further analysis. Thank you so very much for listening.
Thank you so much, Mr. Kamoga, for that presentation. I think those of us who enjoy open source now have a new dimension to it, and I would like to invite questions concerning that. Do you have any questions from the audience?
Thank you so much for the nice presentation. My question was around the reference data sets that you used were for 2017, and the data that you used from OSM was for 2021. I would believe that if that reference data set is for 2017, if someone has, let's say, a building, they might decide to change like a layout of the building, and you find actually the building changed. So couldn't let's say couldn't we get like a high resolution image of that is current, whereby we can be able to extract maybe building footprints using, let's say, machine learning, because also digitizing is prone to human errors. So if you create those, like you're trying to create data from the data you've gotten from Entebbe, that is secondary data that you're getting. So couldn't it also be prone to human errors? How accurate could that digitizing be? Thank you.
Should I answer that before?
Yes, you can answer.
Thank you. That is a very good question. And actually, that was one of the main challenges of this research. But what we did, we used both. We used machine learning and then the digitization, and then we compared the results. But actually, to come up or to overcome that challenge, our first objective did that we worked on only buildings that match one-to-one cardinality, that we can edit all buildings that are not in the match. And we compared the shape, and then we compared the overlap, so that we can basically an average or the weighted mean of all the results, all the buildings that have been assessed in the given area. So not basing our assessment on a few buildings. We have assessed them, we have had enough sample to come up with these conclusions. So we worked on, like in total, in general, we worked like on close to 30,000 buildings. And with that, I'm sure you can come up with a better result. Though we can recommend this to be carried out in other areas or a bigger area, but this is what we have to do. So we have to have enough sample, big enough to counter for all those.
Okay, if there are no further questions, thank you so much, Mr. Kamoga. We can now invite Mrs. Yvette Naturinda.
There's a question from Zoom. From Henry Chiza.
As you prepare the presentation for Ms. Natrinda, maybe we can have Kamoga comment on that. How was the data validated or checked on ground?
So what we did, these images, these orthophotos are basically high-resolution images, and you can easily identify the building footprints in the image. So that was enough validation. So, but what we did, the ground validation was purely about the attributes. We had to sample out a few attributes so that we can compare them with the ones of OSM. That's the only ground truthing we did. But for the building footprints, we used high-resolution images, so they were able to be extracted, and we used two methods. We used machine learning and manual digitization, and they were matching purely well as compared to shape.
Okay, thank you. Ms. Natrinda, you can please go ahead with your presentation.
name is Yvette Naturinda. I'm currently pursuing my master's here at Makerere University, doing a master's in Geoinformation Science and Technology. Today I'm going to be taking you through the planning approach to counting buildings from remotely sensed images. With the following people, we worked on this research. Like the stayed there. Sorry. All right, background. There has been an increase in the population growth over the years, as you can see according to the chart. And this has led to urbanization and urban development, which is evidenced in this image that we are looking at of Kampala. If you compare the image for 1985 with the image for 2019, you can see that the level of green has reduced, and it has been encroached on, especially by buildings and other developments due to urbanization. Due to this, there is a need to monitor urbanization, and in particular, density. Different methods have been used to quantify building densities, but one of the most used one is the manual method. But this method is very tedious and time-consuming and very costly. But over the years, in the recent years, there has been a development of artificial intelligence that can automatically or automate the process of counting buildings. Sorry. Yeah, sorry about that. Yeah, so in the recent years, like I was saying, there's been a development in artificial intelligence that can manually count buildings. So there has been growing capabilities to automate the method to detect and count objects in high-resolution images. And these methods have been using artificial intelligence that uses deep learning to automatically detect buildings using convolutional neural network architecture. So with this new development, we can be able to automate the process of quantifying building densities. So the problem statement and the objective of this study was establishing statistics on building densities is very key in urban planning and monitoring, but it is also very laborious to carry out such surveys. Improved traditional methods have been used, which involve human interpreters that directly count images from high-resolution images, but this itself is also very tedious and also very subjective. Therefore, the aim of this research was to apply deep learning using convolutional neural networks to automate the counting of buildings in high-resolution aerial images. So the methods used, first of all, we collected drone data. This was at Kabanyoro at Muarik, Makerere University Research of Agriculture Research at Kabanyoro. So we managed to pick buildings around Makerere University. And while we were picking these images, they were picked at different altitudes. That was 250, 300, and 350 feet above the ground. And we did this so that we can have different resolutions in the images that we are going to acquire in order to be able to detect images at different resolutions, to be able to detect buildings from images at different resolutions. So the acquired images were later split into different sizes. That is 1024 pixels by 1024 pixels. And we did this because the model that we are going to use, that is convolutional neural network, takes in that kind of data as training data. Yeah, so we split the images, and then we had to do what they call data augmentation. Data augmentation is a technique of increasing training data, and you do this by getting that same data that you have, but then you modify it a little bit. So we did this in 6 ways. That is, we applied the vertical flip, the horizontal flip, then both the vertical and the horizontal flip, the rotation at 180 degrees. We also raised the hue level. And yeah, so that means that we multiplied our images by 6. Yeah, so we were doing all this because deep learning algorithms require a lot of training data to be able to get something that is very accurate from them. So we split this data into training and testing. That was 90% for training and 10% for testing. So this data was also annotated, and during annotation, this is creating bounding boxes around the objects in the image that you want to identify. And these bounding boxes are saved as text files, and they basically tell the model where exactly in the image the object is located. So we did annotation, and later on we trained our object detector, which is called YOLO algorithm. YOLO is you only look once in full, and it is it uses the convolutional neural network architecture to be able to detect different objects in an image. Yeah, when you see here down, it shows you basically how it works. So you feed it with an image, then it splits this image into different small images using a grid, then also creates bounding boxes in each of the grids. Then it attaches on these bounding boxes the probability that this bounding box contains the object that you're trying to identify or not. So after attaching the probabilities, then it gives you a model, what we call the weights file, which is what you later use to identify the object that you've been training on other images. Yeah, so after doing that, we got the weights file, and we were able to apply it on our testing data. Yeah, so with that, we were able to do object detection, and from that, we now needed to do the counting. Yeah, so the counting, we used SORT, which is simple online real-time tracker. It uses the Kalman filter that tracks an object from one image to another. So this was very important in counting because sometimes you find the buildings are similar to each other, but with this filter, we're able to differentiate and actually come up with a total number of buildings in an image. Yes, so after doing the counting, we obtained the number of buildings in the image, and then we had to do validation. So this shows an example of augmentation. Like I said, it is used to obtain a variety of images. And when you look at the further left, you can see the original image the way it was. So it was annotated in the next, and then it was flipped horizontally, vertically, horizontal and vertical. Then we had to do the rotation, average blurring, and also raise the hue. So when you're doing all this, you're introducing to the model different situations of your object, so that when you give it a new object that it has not seen before, it is actually able to detect it. Yeah, so these are the results for the building detection. Yeah, as you can see from the images, the algorithm was able to detect the buildings in the image. Though we had a few challenges, if you can look at the middle image, there is a very small building that is in a yellow box. Yeah, so because the buildings have different sizes and different shapes, the model was not able to detect some of the small buildings, and that was a challenge. Okay. So these are the results for the counting. When you can see on the further left, you can see that in the first image, the model was able to count 9 buildings in that image. Yeah, then the following one was 11 buildings. And then lastly, we had, about 9 buildings. But yeah, to detect all this, we're using SORT, like I said earlier, that uses the Kalman-Fichte filter to track the different objects across the whole image. Validation results. So the performance of the model was evaluated using precision, recall, and F1 score. But the overall performance was 0.7, which means that 70% of the buildings in our images were correctly detected and counted as buildings. Yeah, discussion of the results. The developed algorithm was actually able to detect the buildings with an accuracy of 0.7. The errors that were obtained were due to the difference in the sizes of the images and also the difference in the resolutions of the images that were used to train and also test. Yeah, so these errors can be greatly improved with more training data, because like I said earlier, the more training data you give to the model, the better the accuracy, the better the results. So these errors can be better improved by giving the model more training data and also of a different variety. Also, clustered buildings seem to be a complex situation, because you have a situation whereby buildings are very next to each other, which makes it hard for the model to differentiate them or detect them. Yeah, so to improve the performance of the model would need to be trained with more iterations. Yeah, for this one, we trained it with 4,000 iterations, but the more the iterations that you use, the better the results that you actually obtain. Yeah, so conclusions. Yeah, so conclusions. First of all, object detection can be carried out using deep learning techniques, but all this can be improved by giving the model different kinds of data to be able to detect buildings in different conditions or situations. Now, although the developed model was for counting buildings, it can also be applied in different areas. For example, it can be applied in areas like livestock detection. It can be applied in areas like tent detection in refugee camps and many other areas. So the challenges that we encountered, although they were difficult to overcome, they had a relatively mild impact on the accuracy that we achieved. And given the limitations of the current data sets, retraining the models and increasing on the number of iterations that you're using improves the results of the model. Yeah, thank you for listening.
Thank you, Yvette, for the wonderful presentation. Now I'll ask if there are any questions from the audience.
Thank you, Yvette, for the wonderful presentation. My question is, given the vast applications this model could really, or this study could really help us with, especially if you look at the previous presentation about OSM, what are the prospects of this doing more than just counting? For example, if you are to apply it in OSM, you really need to get other aspects such as the complete architecture, perimeter, maybe even size of the building. So is there any prospect for it being improved to capture those aspects?
Okay, if I can answer your question.
Thank you, Vet, for the presentation. The first one is kind of related to what Derek has asked. What was the motivation for you to apply the model in counting buildings? Is there any application that is fundamental to the counting of the buildings? What was the motivation behind you counting the buildings? Then secondly, you talked about when you are acquiring the data for the buildings, used altitude, you said 300, 350. Why the 300 or why the 350? Why not 100 altitude? Why not 1,000? So what did you base on to select that altitude? Thank you.
Okay, thank you for the questions. I'll answer the first question first. What are the prospects for this method? So starting from the fact that actually when you're using this method, you do not need to know the width of the building or the height of the building. All you have to do is feed the model with your training data. So you're going to look at your area of study and identify the different kinds of building or the different situations in your area. So then you pick test data for all those buildings and then you feed them to the model. So now the model learns over time, like the was talking about iterations. So it learns over these iterations and it is actually able to identify for you the different kinds of buildings. And then now when you talk about applying it to the OSM part, this was basically object detection and counting, but there is also object classification and masking, whereby you can apply also convolutional neural networks, but then it masks out for you the buildings. Yeah, and then you're able to actually use them elsewhere. Yeah. Then going to Christine's question, what was the motivation? Like I said earlier, there is a lot of urbanization happening, and we need to do urban planning. One of the ways that we can do this is to monitor the weather buildings, the developments that are happening around us, which includes the building. So when you're able to do that, then you're able to plan better for the city, for the policymakers. Yeah, and something like that. Yeah, then the second question was about, yes, the altitude that we chose. First of all, when you're flying a drone, there is a limit to how far you can go. So that was the first factor that we considered. The second reason was that the altitude that you choose, also you have to be able to cover a large area that you're looking at. So that was the second factor that we considered. But also the third factor was that you need to be able to see the buildings that you're going to count. So if you are very high, that means that you might not be able to look at the buildings, hence you won't achieve your objective. So those were the three things that we considered. Thank you.
Thank you. Do we have questions online? Okay, I think someone was appreciating you, or okay. I have a question myself. Is your model aware of reflectancy, or can green roofs be square green roofs be told apart from square gardens that are green? Is your model able to do that? Then how were you able to solve the failure to observe small buildings, since the data was already fed to the model?
The first question, the model looks at the shape and the size of the buildings as of now. It does not look at the reflectancy. Yeah, so it majorly depends on the shape and the size of the building. Yeah, and the shadow or something like that, yeah. And yeah, answering the second question,
The failure to observe small buildings?
yes, failure to observe small buildings. So we had to keep feeding more training data to the model, but also increasing on the number of iterations. Yeah, so, and when I talk of increasing on the number of iterations, of course, you reach at a level and the model starts overfitting. So you also have to put that into consideration. Yeah, but solving that, we had to go on and now feed the model with smaller buildings or images at a very low resolution where the buildings are really small, so that it can also learn how to identify them.
Okay, thank you so much, Yvette. If we have no further questions, we can invite the next person. That's Mr. Joel Chitutu.
Okay, thank you very much, Chair and colleagues in your respective capacities. I greet you all. Joel Kitutu is my name, and I stand here wearing two hats. One of them is the hat of the Department of Geomatics and Land Management, where I'm a child, right from bachelor's to master's. But the second hat is from Uganda Red Cross Society. So I'm a focal point there in emergency preparedness and response. And I think the theme for this conference aligns well with what Uganda Red Cross Society does. And I'm glad to be given a chance to make a presentation that stands between these 2 points, from the geomatic side, but also from the emergency preparedness and response. My presentation, I emphasize, is in the middle there, because more often than not, the hard science that is generated from the side of the academia is always an issue that people ask many questions about. How does this translate to real solutions? So where is the application? And that's a gap that I try to bridge in my presentation. So I'm looking at spatial modeling of flood impact and community resilience in an area called Eastern Uganda, and this is Bukedi, Elgon, and also the Teso region. This work was done under supervision of Dr. Lydia Mazikayondo, and I'll go straight to the outline. You will help me with this technology. Can you just move the slides there, if you don't mind? Yes, so this is the outline of my presentation. I'll take you through the background, problem statement, up to the recommendations. And so, what is the background to this work that I did? You and I know, if you have been following the media reports, that a lot is happening in terms of disasters and emergencies in the country, and there is an increase in the events. So what was happening 10 years ago, it's happening more rapidly today. We have an increase in hailstorms, floods, and other hydromet disasters or hazards in Uganda. And the Far East, which has a population that translates to 14% of Uganda's population, according to the projections of UBOS. However, most of the resources that are channeled towards emergency preparedness and response, they are always on response. Little is done in terms of building resilience, especially at community level. So ideally, what happens is there is a flood event, and it's in the media everywhere, and nothing happens after. And the same reoccurs. So the question is, how can we build community resilience to support the communities, develop solutions, working together with the other stakeholders to be able to manage these situations? This particular work identified spatial patterns. That's the underlying relationships between something called resilience, which has many faces, and what we call flood impact. And to put things into context, here when I talk about flood impacts, I'm looking at the effects of the floods on the communities that are vulnerable to that particular hazard, flood. And community resilience, I'm talking about the capacity of the community to resist the impact of the flood, but also to cope with the after effects. So here, I just had to put for you a map so that you appreciate the area I'm talking about. That is the Far East. At the extreme top, it's Teso, that is Katakuya, Muria, Kapelebiong. You come down to Soroti, and down in the southeast, we have the Elgon region, that's Bugisu and Kapchorwa. And the photos to the right, they're simply showing the flooding that's happening in the gardens, and also a house that has been affected, it has been damaged. I think ideally I can say it has been destroyed by the flood. Yes, so what is the actual problem in relation to academia? Here we actually see a knowledge gap. A lot of the work that has been done, and when you consult literature, it's around hazard, risk, and vulnerability mapping. Little is done on modeling the underlying relationships between especially the impact and some of these hazy indicators which are cross-cutting. Because from the geomatics side, we always look at the more natural science, built environment kind of indicators. But when we talk about the community, we have to integrate the other socio-economic aspects, which sometimes are hard to determine, and we sometimes have to use proxies. So we have to define what we are saying. And therefore, this knowledge gap is what necessitated the execution of this work. The objective, the main one for this work, was to explore the influence of community resilience on flood impact in hotspot areas for floods. And the specific objectives were, one, to identify the flood hotspots, and also cold spots and regions where there is no clustering. The second was to determine those key factors that relate to resilience that can be used in eventual weighted regression, geographically weighted regression. The third was to examine the relationship between resilience and flood impact. And here up, we do have the research questions that are associated with the the specific objectives, one of which is what are the flood hotspots, looking at the geography, and also secondly, what are the key factors influencing flood impact, and thirdly, the relationship between the resilience and the impact. So here I have a flow chart of the methodology. I hope you can see well. The green item, the first one is data collection and collation. So data was collected in twofold. The secondary data from the archives, one of which is the UN Deciventa database, which in Uganda is being managed by the Office of the Prime Minister. There is incident data there for various hazards and disasters. I picked out the one for floods, and this was subset to the study area, and hotspot analysis was run on it to generate what was used in the subsequent work as the dependent variable. The second was primary data, which helped to do a bit of validation on the indicators. So a bit of field work was done to confirm or to validate some of these things which were in the secondary data. Exploratory regression was run on some of the data that was picked to identify which specific indicators, these socioeconomic indicators, can be used to do the modeling. So here, ideally, the exploratory regression identified 5 factors which were modeled together with the dependent variable and the tool which is GWR, and the output were coefficient raster surfaces that help to explain the underlying relationship between resilience and flood impact. And that, in a way, generated recommendations that I must say are being used. Currently, there is a lot of flooding happening, and this work is informing actual interventions in real world. As I said earlier, when we talk about resilience or community resilience, there are many perspectives. People define them differently. So there are so many frameworks that are used to determine or to define resilience. The specific one that I used was from someone called Chan et al. With the colleagues, 2014, and it's what is displayed here. And it was just contextualized to the studies context. So we do have different dimensions, the first being science and technology at the top. The second is the built environment, which is more related to what we understand here in geomatics. The third is organization and institutes. The fourth is the natural environment. And the fifth and last is the socioeconomic status. What you see in yellow and blue, and I think orange or brown, those are the study indicators that were used, some of which are just proxies. Because as I say, this is a socioeconomic way of looking at things. Looking at those specific indicators, how do you get them into something that can be run within the scientific tools, the modeling tools, to get sense out of it? And then the diagram, which is on the right, is just simply showing the interaction between those different dimensions. Yes, this is again to help you appreciate what was done during data collection. There were field visits that were done, and these are just people from Uganda Red Cross Society that helped with the actual field visitation and focus group discussions and the rest that was done in the field. And here we do have a photo to the left where I conducted a focus group discussion in Butaleja, one of the areas in Bukedi sub-region. And to the right, we see a field of potatoes that has been affected by floods. The algorithms that were used, the first is the hotspot analysis for the first objective, to identify the hotspots, cold spots, and regions where there is no clustering. The second was exploratory regression to simply identify the factors or the indicators that make sense in terms of looking at flood impact and resilience. Then the third was the geographically weighted regression tool that was run on those identified independent variables with the dependent one, which was the flood impact, to eventually see the underlying relationships. And the results, the first, the data collection. A lot of data was collected, both secondary and primary, from the archives and also from the field. The hotspots were identified, cold spots, and also those regions of no clustering. And then those factors which are influencing flood impact were also identified. And lastly, the coefficient rasters were also generated from the tool. This is the data that was used. Quite so many things, but of course you will not be able to see the rest. So I put only the key things here and some of the indicators that were used. But also I put the source so that you appreciate that this is actual data. It has a source, and you can validate from, for example, the district reports, the DDMCs, those are district disaster management committees, from the CAOs, and from the other sources, including Uganda Red Cross Society, which does a lot of work on the ground there through their branches. Yes, this is just a continuation of the table, showing the areas up to sub-county level, the XY points that were reached in the validation exercise in the field, and the different values that were collected for the different indicators, both of course from the secondary and what was made to make sense from the primary. Yes, so the output, the first is just simply a map that shows the clustering, and the hotspots were identified in Teso region, somewhere called Katine, Arapai, and Kamuda. These are sub-counties in the Teso area. The cold spots were in Buhalu and Bunambutie. This is an area in the Elgon region, specifically Bulambuli. And the third were the regions of no clustering. That was in Butaleja, down in Bukedir sub-region. So from the disaster data, Teso region can be seen as an area which is likely a flood impact hotspot. The Elgon, flood impact cold spot. Here when I talk about hotspot, I'm meaning that area where there is clustering of high values of impact, and cold spots where there is a clustering of low values of impact. And then regions of no clustering where really there is no clustering at all. And for the exploratory regression, I said there were very many indicators that were collected, but we wanted to see which of them makes sense in terms of flood impact. So running that exploratory regression, it eventually generated specifically one model. It pointed at a model which has child-headed households, temporary roof type, temporary wall type, subsistence farming, and nearness to river or stream as the model which satisfies some of the regression diagnostics. There's a lot of checks and diagnostics there. I can always point people to the report which details all these kinds of things, because when you are talking about regression, you are aware there are so many things to look at to ensure that the model passes. For example, the adjusted R squared value, AIC, GBV, and all these others. But here, these graphs are simply showing these 1, 2, 3, 4, 5 indicators that were used eventually, and mapping them against the flood impact. So looking at the flood impact on the y-axis and each of these indicators on the x-axis and looking at their behavior. This particular one was looking at the correlation to just see if there is any kind of correlation between these particular indicators and flood impact. So as I conclude, here I do have the maps of the different coefficients for those 5 indicators. And the first one there is the map that we have already seen for cold spots, hotspots, and regions of no clustering. The second is simply showing the influence of child-headed households, that indicator, vis-a-vis flood impact. So we can see from the downer side, that is the southeast towards the northwest. You can see it fades away, the influence of child-headed households, that indicator, vis-a-vis flood impact. It fades away to the Teso region. Ideally, that means that child-headed households is an item that should be attended to when we are looking at resilience to flood impact. And the rest, as you can see, an autocorrelation using Moran's I was run to test for randomness, and the model passed. And finally, I want to bring you to the discussion. So what does this mean? That's where I'll end from. What does this mean? How does this science translate to actions? That's what we are looking at here, what I'm discussing. So for child-headed households, there is something that comes out of this study, that child protection to reduce the child-headed households should be attended to by the Ministry of Gender, Labor and Local Development, Gender, Labor and Social Development. That is an area that should be attended to. And this will promote disaster preparedness at household level. Looking at child-headed households, these children really, if they are the ones heading households, they cannot ensure good structures which are resistant to floods and many other things. For the temporary roof, temporary wall, promoting construction of houses with permanent or more robust kind of walls and roofs is recommended. And nearness to the river, enforcement of restriction. Some of these things are already known, but they are not enforced. So the study just paints out some, scientific evidence that can help those people who deal in these areas to enforce. And in conclusion, we can see that community susceptibilities and adaptive capacities, which in this sense were the resilience indicators, they greatly influence how that region is impacted by floods. The characteristics of the building material and other socioeconomic characteristics, they play a great role in the influence. And this information, definitely that was produced, is scientific evidence of the underlying relationships. Things which sometimes we take obvious, but eventually when you run some of these GIS tools, you eventually reveal some interesting patterns that can inform action. Thank you very much. This one are just recommendations for further research. For example, for research, more data should be collected, incident data. There is trouble recording data in Uganda. So things happen, we see them on media, but when you look for that data, you don't find it. How many households were affected, damaged, and all these things. There are very many gaps in there. Further research can be conducted to develop algorithms that are specific for these hotspot areas so that more can be known. For the community leaders and government, sensitization should be done in these high-risk areas. And also interpreting, translating some of these weather forecasts that we see on TV to help some of those farmers and people living in those areas to be aware, to be prepared, to also help them, to build resilience mechanisms from the ground. Government always has the tendency of telling people what to do. But I think the new approach is work with the people so that you generate people-centric solutions. Thank you very much.
Thank you so much for the presentation, Mr. Joel. So I will invite questions from the audience. 2 questions. Okay, I see that we have no questions from the audience, but we also have no questions from the online team. However, I would love to ask my own question. I know that Bukedia is part of the stubborn Aoja catchment with the floods. And I see that in your analysis, it comes out as a cold spot. How is that? I thought Bukedia is one of the places affected.
Yes, that is, I think, part of TESO, right? Yes, and from the data that was collected, it pointed out hotspots actually in that area. The skewing that is there, that shows maybe a little bit of an anomaly, is because of the gaps in the data. As I said earlier, incidents happen, we see on TV, but when you go and look for that data, you will not find it. So for example, in September, only 20 records of disasters were recorded because we follow this very critically. But in the media, there are very many, there are around 50. But when you go to the data set, who reports? So that one, in a way, skews the analysis, and you can see some anomaly somewhere. But the general picture is that TESO is a hotspot. The cold spot is the other side as you turn towards Bulambuli and the Elgon and Kapchorwa region, Kapchorwa area. Yeah.
Okay, thank you so much. For those that will develop questions along the way, you can engage Mr. Chitutu. He will elaborate more on that. I will now go to our next presenter. Yes, and that's Miss Brenda Nagula. I'll ask the presenters that we are a bit mindful of the time. We have a timekeeper who will alert you, so you just have to look in the audience and they will alert you when you're about 2 minutes away from closure.
Thank you very much, moderator. Nagula Brenda, a student under the Department of Geomatics and Land Management, Makerere University, and I'm presenting a study that was undertaken to assess the impact of spatial planning on the spread of COVID-19 within Kampala City under the guidance of Dr. Ronald Sengendo, Dr. Frederick Omolo, and Mr. Ivan Bamwayana. This is the presentation outline, and starting with the background, we see that the emergence of infectious diseases is rapidly increasing, and urbanizing regions have become the focus of these outbreaks. And over the past 2 decades, 3 infectious diseases have emerged, with the most recent outbreak being caused by the coronavirus disease, also known as the severe acute respiratory syndrome, COV-2. And it was first identified in Wuhan, the capital of Hubei, in 2019, and was declared a global pandemic on 11th March 2020 by the World Health Organization. And this organization went ahead to issue recommendations on how to control the spread of the virus, but went ahead to state that contextualization and understanding of the dynamics of this virus should be disaggregated to city and country levels. And we see that different studies have been undertaken globally at a localized context to understand how is the transmission of this particular infectious disease and facilitated. And we see that factors related to density, humidity, temperature have been explored, whereas factors related to spatial planning have not been considered among the most critical spheres during this COVID-19 pandemic. Why spatial planning? We see that from other previous pandemics that have occurred over time, such as cholera, the Spanish flu, the plague, we see that spatial planning played an important role in understanding the dynamics of those particular pandemics, and after which control measures were developed. So, what is spatial planning in itself? It looks at the way land is being used in a particular urban area to meet the demands of commercial, industrial, residential, and institutional development. It dictates which developments should occur in a particular area, how they should occur, and when they should occur, looking at the land use regulations and how these regulations facilitate activities within a particular area. So the UN Habitat in 2021 suggested that decision makers must not only understand how urban environments are being affected or are contributing to the spread of the virus, but they should also consider how to build urban pandemic resilience. How does spatial planning also come in this particular instance of building pandemic resilience? We see that it can be used to develop the appropriate design of urban spaces, identifying the main focus and better control of these places, and also changing them into resilient and desirable spaces. So, what is the statement of the problem? What is the problem that this research sought to address? We see that cities have been at the focus of the COVID-19 pandemic, and different strategies have been adopted to curb the spread of this particular infectious disease. However, we see that irrespective of these different control measures that have been put in place, we see that curfews were adopted, limiting public gatherings, total lockdowns, and closure of schools and contact tracing. We see that even though at a particular point that the curve flattens, we see that other waves continue to come up. So what is exactly contributing to the constant spread of COVID-19 in particular spaces? We see that Karnanayake in 2020 stresses that the spread of COVID-19 could have been spread had there been proper implementation of spatial planning guidelines, meaning that spatial planning could have played a part in the way COVID-19 spread in particular spaces, but no empirical research has been undertaken to assess the impact of spatial planning on the spread of COVID-19, particularly in the context of Kampala City. Why Kampala City particularly? Because we see in Uganda, it has been the major focus of COVID-19. It has been the epicenter of this particular infectious disease. So objectives were set so that the purpose of the research is attained. And the first main objective looked at assessing the impact of spatial planning towards the spread of COVID-19 in Kampala City. It was broken down into 3 particular specific objectives. The first one looked at exploring or determining the spatial distribution of COVID-19 cases within Kampala City. Where are the disease risk sites? Which areas are registered high cases of COVID-19 as compared to other areas? And then the second specific objective looked at evaluating conformance towards spatial planning on the spread, conformance towards spatial planning standards within Kampala City. In that we see that yes, this land use regulation has been set, but does the area actually conform to the particular land use regulation that has been set? And then the third objective looked at modeling the relationship between conformance to spatial planning and the spatial distribution of COVID-19 in Kampala City. A methodology was adapted as displayed on the screen, and the data that was first of all collected, we attained a national case list database from the Ministry of Health Uganda that detailed the different COVID-19 cases that were registered in different areas within the country. And this particular national case list database contained information or fields on the district where the case was registered, the type of transmission, was it local, was it imported, and then the parishes and the sample collection points where the particular positive case was collected from. And then we also, this case list database also attained the number of contacts that were attached to that particular positive case that was registered. And then basing on the particular location of where the positive case was registered from, it was geocoded and attached coordinates. For instance, we see that from the cases that were registered, if the case was registered in Chikubo, it was attached a coordinate of Chikubo so that it can easily be mapped. So we went ahead to assess the spatial distribution of that part of the cases within Kampala City using spatial autocorrelation and Einstein's indicator of spatial of spatial association. The global spatial autocorrelation displays results in relation to, is that distribution randomly distributed? Is it clustered? Is it dispersed? And then the local indicator of spatial association disaggregates these particular cases at a local level and goes ahead to display the hot spots and cold spots at a localized level. Then to establish the spatial planning adherence within Kampala City, a Kampala Physical Development Plan of 2012 was attained from Kampala Capital City Authority, and it was used to state which areas were demarcated for a particular use, to particularly show what was actually planned. And then the existing situation was also attained using a high-resolution satellite imagery of 0.29, ground data, and also parcel boundaries from OpenStreetMap. And then these two were evaluated using post-classification change detection, and then conformance to spatial planning was attained. These two particular results were used to model and ascertain the relationship that exists between spatial planning and the spread of COVID-19 using a geographically weighted regression. So these are the results that were attained from the analysis from the data that was collected and the general prevalent characteristics of COVID-19. It is important to note that this particular study looked at the first phase of COVID-19 within Kampala City, and that is for a period of March 2020 to March 2021. And in this particular period, the stage of development for COVID-19 cases within Kampala City can be categorized into 3 stages, whereby we see a stage of low transmission, rapid increase in transmission, and also the end period. So what could be attributed to the first initial stage having low cases of transmission? We see that after the first case of COVID-19 was registered within Kampala City, there was a quick response in terms of a partial and total lockdown, limiting public gatherings and closure of institutions and schools. So in this particular period, there was a low transmission rate, after which between August to December 2020, we see the cases increasing, like the transmission increasing in Kampala City. So this is attributed to the fact that there was a release of lockdown, whereby public transport was allowed to move, and different public gatherings were allowed, and we see that also the lockdown measures were released. So we also see an end period, that is from January to March 2020. And according to the model that explains the transmission over time of infectious diseases, that is the susceptible infected removed model by Hunter, it explains that at the start of the pandemic, more people are susceptible to COVID, to like an infectious disease. They go on, they get infected and go on to infect other people. But after which, the disease reaches an equilibrium in that people are less susceptible and more people have recovered. So we see that the curve either drops or reaches a flattening level. So when we come to the spatial distribution of COVID-19 cases within Kampala City, assessment through the spatial autocorrelation, that is to assess how are the cases distributed within Kampala City, we see that the Global Morans Eye Index statistic shows that the overall number of COVID-19 cases tended to be randomly distributed in space. Why is it like random? Why is it that the probability of picking a particular value of COVID-19 is independent of the same value that is picked at a neighborhood location? We see that different dynamics are occurring within Kampala City. We see that different parishes have different dynamics. They have different land uses, they have different populations, they have different activities going on. So that that influenced like the random occurrence of high cases and low cases within a particular area. And this result is as per the global Moran's eye. So we went ahead to decompose this global Moran's eye at a local level and understand how are the dynamics of COVID-19 at a localized level, because the list of statistics goes ahead to quantify the distribution of a particular variable to a localized level. And we see that the central division, basing on the optimized hotspot analysis, is the epicenter of the virus. And why is it so? Because we see the transmission characteristics of COVID-19 increase with our increase in activity, increase in movement of people, increase in contact between people, and the population, according to the KCCA statistics of the central division, that the population, the daytime population of people increases with a high influx of people up to 4.5 million people during the day. So, and these particular people come to undertake different activities. And therefore we see that through this, the different activities that are occurring, they are causing central division that hosts the central business district having very high cases of COVID-19. And this particular map shows which particular areas that, okay, we have the central division being the core of COVID-19. But then we also have those particular places that are hotspots, that are areas that have a high concentration of COVID-19 infections. And those are Nakasero 1, Nakasero 2, Nakasero 3, and Kagugube. Whereas with movement away from the city center, we see that the cases of COVID-19 reduce. So towards conformance to spatial planning, analysis was done basing on what was planned and what is actually existing. And a change was calculated that in this particular year, mixed use was planned for 0.8%, and in 2021 it is at 2.44%. And we see that from that particular trend, our mixed use registered a positive non-conformity of attaining more land than what was actually planned. And from this particular trend, it shows that land use pattern in Kampala is changing from an extensive, that this particular land is demarcated for this particular use, and it is changing towards an intensive, that we are requesting for all, that land is demanding for land use densification, compact development, that we need like land that is for more than one use. So, assessment of the extent of conformity in regards to area within Kampala City, we see that conformance is there, particularly in the residential use, but then also non-conformity is spread throughout Kampala, showing that there is an instance of piecemeal planning within Kampala City. And non-conformity is registered more in the central division. And if we are to look at the neoclassical model that looks at land rent, that land rent within Kampala City, within the central business district, increases and requires for land that ensure profit maximization. And we see that land that was demarcated for inner city residential has been inherited or has been replaced by commercial and mixed use that command for higher profits as compared to residential. So, in modeling the relationship between spatial planning and the spatial distribution of COVID-19 to actually attain what is the impact that exists, we see that in relation to land use, and we demarcated the dominant land use in each particular area, and this was matched to the COVID-19 cases that were registered. And we see that with movement to the suburb divisions that are predominantly residential, cases of COVID-19 reduce. And why is it so? That in residential establishes our management that ensures privacy and limiting contact with the outside, whereas the users that are located closer to the central business district that highly encourage accessibility and connectedness bring about interactions and hence registering high cases of COVID-19. And we see that, yes, we see that this particular use encourages high and low cases of COVID-19. But does it conform to the spatial planning standard or guideline that has been set in that particular area? We see that in relation to conformance or adherence to spatial planning, areas that adhere to spatial planning standards at a generalized level have a negative, like there is a negative correlation between the spatial distribution of COVID-19 and conformance to spatial planning within Kampala City. In that areas that do not adhere to spatial planning register the highest number or the higher cases of COVID-19. And the geographically weighted regression indicated a relationship, and in that spatial planning can only explain only 0.51% with an R squared of 0.1%, but we see that this particular relationship or explanation of spatial planning to COVID-19 is not constant over space. So we went ahead to look at the local R squared, whereby this local R squared shows that there is a moderate relationship of spatial planning explaining occurrence of COVID-19 in a particular area, and that is showed by red. The R squared goes up to 0.43 to 0.61. Whereas in those particular areas that are lighter, we see that spatial planning in those particular areas could not explain very well why COVID-19 is occurring. So the recommendations and conclusions, we see that with adherence to spatial planning, there is less risk of transmission of infectious diseases, and mostly in areas that are demarcated for a particular use. Therefore, basing on the different results that were attained in this particular study, it revealed that spatial planning alone could not explain the spread of COVID-19 within Kampala City. Therefore, there is a need for a multidisciplinary study that focuses on different aspects contributing to the dynamics of COVID-19 within Kampala City. And also in relation to our spatial planning, we did not go into looking at how the building layout, how the density within a building intensifies the spread of COVID-19. So further studies are also needed in relation to that. Thank you very much.
Thank you, Brenda, for your presentation. I'm sure most of us are experiencing COVID, and you are able to point out your area within our work. So I invite your comment on the same. Do we have comments, or the talk on COVID scared us? Yes, we have a comment from Prof.
Thank you very much for the presentation and also for the study. Maybe everyone fears COVID. That's why people are not answering. And I'm also scared because I didn't see you sanitizing this microphone, which you brought to me. Maybe this should be my last. So, first of all, thank you very much. I've already thanked you, but I was wondering the motivation for this study on the impact of spatial planning on COVID. We all know the causes of COVID. If you cluster people, you increase the transmission. But when people are separated, I think the chances are a bit lower of contracting COVID. So do you have any theory that links spatial planning in particular to COVID, apart from the known causes of the transmission, which is the clustering? Then number two, I see you are using Moran's autocorrelation I. What are you correlating COVID incidences with? Because I didn't get it properly where the autocorrelation came in. Because I thought autocorrelation means where you see this, then it should be related to this. So, but I note one of the variables is COVID occurrence, but I didn't understand the other variables. Thank you.
Thank you very much, Doctor, for the questions. And the theory that relates spatial planning to COVID-19 is particularly in relation to public health and how from previous pandemics and from literature that from previous pandemics we see that COVID-19 or infections or outbreaks of infectious diseases greatly are influenced by how the uses within particular areas are being put to use, how land in a particular area is being put to use. And the understanding is from other previous pandemics that have occurred, dating back to actually what John Snow analyzed on what was causing infections and related that to the use of a particular borehole in a particular area. So that particular aspect of from other previous pandemics that spatial planning played an important role. It led to a motivation in this particular study and hence being explored in relation to COVID-19.
There was a question on morons. What were you correlating?
In relation to morons, I was correlating the incidence of COVID-19 in relation to a particular location or a particular parish. That yes, we have incidence of COVID-19, but at a localized level, are they actually like related to at a parish level? Is there a correlation between a location at a parish level and the spread of COVID-19? So in relation to the Moran's eye, that was the correlation that was actually assessed.
Okay, thank you. There's one more question there.
Yes, thank you very much for the presentation. Basing on what you said, like for example, in case they had to find a case in Chivukubo, they attach XY coordinates onto that. So how did you cater for the movement of people? Because you may find somebody works in Chikubo but maybe stays in Nakawa or Kawempe.
And we see that, thank you very much for the question. And by the mere fact that a person is in a particular area like Chikubo, and we look at the intensity of activities, and we looked at also the National Case List database also had a field on the type of work that that person does. So in a particular area like Chikubo, and we look at the type of work that the person was doing, and this is a business person, that particular attribute was used to attach the incidence of COVID-19 in that particular area, that this person is a business person, he's in Chikubo, Chikubo is a business area, so they could have gotten COVID-19 from that particular environment.
Okay, Brenda is still with us for purposes of time. Those who still want to engage her can find her in a comfortable seat. So we have two more presentations between us and lunch, and we know that it's very hard for a person to concentrate when you're in between them and their food. I'll ask the next presenter to be very time aware. So let's have Davis engage us for the next 10 minutes as Charles also prepares.
Good afternoon. Good afternoon. My name is Davis Semwanga. I am pursuing a master's degree in geoinformation science and technology. And I am undertaking a study to quantify the spatial variation of the effect of COVID-19 on property market activity in Kampala using geographically weighted regression, or WGR. And those are my co-authors. And that is the presentation outline as specified. We are saying that COVID-19 is here. It knocked on our doorsteps. We appreciate it. We took it in. There are various ways it has affected people in all ways. We see that COVID-19 started in China, December 2019. However, the disease quickly spread to the rest of the global world. Consequently, the World Health Organization declared it a global pandemic. And just like the rest of the world, Africa and Uganda were not spared either. On 17th March 2020, the government of Uganda imposed a number of restrictions or measures, which included, among others, partial lockdowns, total lockdowns, and also following of standard operating procedures in a bid to control the spread of the virus. However, even those did not curtail the spread of the virus. It continued. We moved from the first phase, we moved into the second phase. However, this study will concentrate on the first phase of the outbreak of COVID-19. The measures that were installed by the government to curtail the spread of the virus had implications. One, people lost their jobs, unemployment levels shot up, the mortgage markets were disrupted, and the real estate sector itself also was disrupted. Several theories have been taken and have been understood that after the outbreak of COVID-19, property markets or property transactions were affected. However, the effect has been on a global scale, and it has not been brought to a spatial variation. We can see, prior to the outbreak of COVID-19, the headlines were Uganda's housing market is gradually improving and growing. However, during the outbreak of COVID-19, these and many questions of this nature moved around. So what is the statement of the problem? We are saying that the real estate sector contributes between 7 to 11% to the to the GDP. And this has been progressing over the years. However, the outbreak of COVID-19 has threatened this continued growth. And from literature, we see that pandemics have affected property markets significantly, and that the effect varies across space, across property types, and over time. Therefore, without quantifying, this study was taken to quantify the spatial variation of the effect of COVID-19 on property market activities in Uganda. And in this particular sense, when we talk about property market activities, we are talking about the volumes or numbers of transactions registered within a particular area. How is it important? When the effect of COVID-19 when the effect of pandemics is quantified, it is very crucial when you're performing a comprehensive evaluation of a potential investment area. You would not want to invest your money in a place that is likely or is susceptible to greater effects. So what are the objectives of the study? To achieve the study, the main objective was to quantify the spatial variation of the effect of COVID-19 on property market activity in Kampala district, with the specific objectives as determining the factors influencing the spatial variation of property market activities in Kampala district, and then to identify hotspots and spatial distribution of property market activities and COVID-19 in Kampala district, and consequently to model the relationship between COVID-19 and property market activities in Kampala district. Kampala district was chosen as a study area, one, because it was, the district accounted for almost 50% of the cases nationwide. And two, the district consists of almost 10% of the country's population, on top of contributing almost 60% to the national GDP. Now, the research methodology is as outlined in the flow diagram, and we can see spatial and non-spatial data sets were obtained, one from the WUBOS, where we obtained the socioeconomic and demographic factors about Kampala district. Then we obtained also the property market transactions registered within the Ministry of Lands, and also COVID data sets from the Ministry of Health. There was an application of the global ordinary squares regression, mostly for diagnostic, and also to determine statistical significance and collinearity between factors. There was a global cluster detection, which was undertaken using the Global Marines Index, and then hotspot analysis was attained using the Gates-Odd, GI-Star, and the optimized hotspot analysis, and consequently, GWR, in particular, the geographically weighted Poisson regression model, was used to model the relationship between COVID-19 and property market activities. Now, the results of the study: one, to determine property market activity determinants. A number of factors were identified from literature, but also it is important to note that these factors vary from one place to another. So to be able to identify the factors that are unique and applicable to Kampala's case, one, we evaluated statistical significance using the p-values, and also the collinearity, where we use the VIF values. These values are set from the rule of thumb. And from our results, you can see that the percentage of the population with access to piped water had the significance level was beyond the required level. Also, the percentage of the working population, the level of unemployment, percentage of the male population, and level of education, those ones were established to be collinear. The exclusion of those factors from the model implied that we had population density, we had access to social amenities in terms of health services and schools, we had the physical characteristics of the properties, to be particular, the land value and the parcel size, and then the literacy levels as being factors that influence property market activities across Kampala. But all those could explain only 31% of the property market activities, meaning that the 69 is explained by variables that are not included in the model. When we go to the spatial distribution of COVID-19, we see with the Moran's index that the cases followed a random distribution with high values basically centered around the central business district and low values in the city outskirts or the residential city outskirts. Also, looking at the population together with COVID-19 cases, you can see that there are areas where the population density is, where the population is low, but you experience high values of COVID-19. Hotspot analysis on the same was carried out, and at the division level, you can clearly identify that the central division was a hotspot area. Locally, parishes that are accumulation of office spaces, high road density, and office spaces were identified as being hotspots of COVID-19. Moving to the property market activities, we see that before the outbreak of COVID-19, the property market activities, the high values were experienced in the outskirts, just as they were in the period during the outbreak of COVID-19. However, during the outbreak of COVID-19, property market activities had a clustered kind of distribution, with the Moran's index being greater than 0. When we superimpose, you look at COVID-19 cases and property market activities, you also clearly see that there is some degree of an inverse relationship, but which we shall interrogate further. You can see that generally the highest number of parishes registered low values of property transactions, and when you look at the distribution of both property market activities and COVID-19, you see the relationship not being uniform. When you look at the hotspots of property market activities, you see that high values of property transactions are registered normally in the northern. Those people who are familiar with the areas of Chanja, Chisasi, those are the areas where property transactions were registered as hotspots. Now, moving to the relationship between COVID-19 and property market activities, we see that the interrogation of the global model returned an R squared of 0.14, meaning that during the outbreak of COVID-19, these factors, COVID inclusive, could only account for 14%. However, the application of the local models, which take into consideration the spatial variability of property market determinants, increased the R squared from 14% to 61%, and with a reduced value of the AIC from 242 to 216. These are diagnostic statistics of the model, meaning there is a better fit with a local model than with a global model. Looking at the distribution of the R squared, or with the model fitness, you see that the highest number of parishes registered a relatively low R squared value, and these were normally within the west and east of Kampala district. The hotspots also suggest that the northern and southern parts of the district registered high values of the R squared, meaning that the model was able to define to a higher percentage within the north and the south. Now, when we move to the coefficients, these are the ones that determine the magnitude of the relationship and the direction. We see that most of the parishes registered a negative relationship, meaning there was an inverse relationship between property market activities and COVID-19, meaning that as the property market activities increased, the number of COVID cases were reducing, or as the cases increased, property market activities reduced. However, there are exceptions as well. There are some areas where there was a gain, meaning that as they had a direct relationship. And an interrogation of the hotspots, you see that the north, the areas of Tinda, Naguru, Chanja, Chisasi, those were hotspot areas. In conclusion, the study attempted to quantify the effect of COVID-19 on property market activities, and the results demonstrated that property market determinants are both diverse in space and time. Furthermore, COVID-19 proved to be had a significant impact on property market activities, which varied across space and with high values in the northern parts of the district and low values in the central and eastern parts of the district. we are also saying that whereas GWR proved to be an effective model of spatial data analysis, it did not show sufficient goodness of fit for all data. And this is because the property market determinants are diverse and are multi-scale. So an interrogation of the multi-scale geographically weighted regression would be able to give us a better fit where we apply property market determinants at various spatial scales. Also, another research should be carried out to take into consideration the property types. For example, you look at the impact of COVID-19 on residential, commercial, and industrial property types, which will not only look at the impact over space, but also across property types. Thank you very much.
Thank you so much. I see the clapping has reduced as the aroma from the kitchen increased. Do we have any questions? Do we have any questions? Yes, Prof. there has a question. Sanitize the...
Yeah, thank you very much for the presentation and also for the study. The impact on COVID on property market activities really is very important, and I appreciate your effort in this. I just want to have one or two questions. The first one is about the choice of the property market activities instead of the value. I don't know what does it give us or what does it help us, because if you have so many activities going on, for example, there are a lot of sales, but the prices are so low because maybe people don't have money or people are selling to get treatment. There maybe we don't get a true picture about the reasons. We see a lot of activity or we see less activity, but does it really inform anything? Maybe that's what I wanted you to clarify, whether also even the value is embedded or whether it would have been better for you maybe to carry out interviews to find out really what were the motivation because as a result of that. Then the time element, I see you are showing us that in these places, there were so many activities here, and in this place there were less activities. But then if you had probably looked even before COVID, would see whether there was any change, because now we see what is happening, but we don't know whether that's normally the normal trend, whether there is COVID or there is no COVID. So I don't know whether it was beyond the scope of your study, or you would recommend that maybe a time element be included so as to actually confirm that these changes are due to COVID. Thank you.
Thank you very much, Professor. I'll start with the first question of value. I think it is one of the factors that were looked at in the model, and those describe the physical characteristics of the properties. That is the average value of land per acre. It was considered in the model, and it proved actually statistically significant, and it did not show any collinearity between the rest of the variables. However, during the spread of COVID-19, land value per acre proved not to be statistically significant. Also, when we talk about the change in property market activities, there was a 79% reduction in the volume of transactions registered before the outbreak of COVID-19 and during COVID-19. So the values we are talking about, that whereas there is a consistency that high values are registered in these parts or parishes within Kampala district, it is just showing that it is consistent. But generally, there was a 79% reduction in the volumes or numbers of transactions registered in the 2 seasons.
Okay, is there any other question? No, okay, so Davis is also still with us. In case you want to sit near him during lunch, you can ask further questions. I will now invite Charles. Charles, you're the very last person between us and food. So I ask that you're mindful of time, but also exhaustive in your presentation.
Thank you, the moderator. The title of the study I am presenting is Operational Framework for Efficient Data Acquisition on Infrastructure Projects using Unmanned Aerial Vehicles for Rapid Value Assessment. I was not on this alone. We worked as a team, and those are the team members. That is going to be my presentation outline. I'll have a brief introduction, the materials and methods considered for the study, the results, discussion, and a conclusion. UAVs. What are UAVs? These are lightweight aircrafts. Some countries prefer to refer to them as remotely piloted aircrafts. Others refer to call them drone. However, they all mean the same thing. They are different from our ordinary aircrafts in that they do not carry on board pilots. These aircrafts mainly have been the preserve of the military. However, over time, we have seen the rise in the use of this technology in the civilian application. You can see from the study carried out by PricewaterhouseCoopers about the drone service market, by the year 2020, that the market was hitting a whooping 127 billion US dollars. And out of that, the biggest percentage of the use of this technology was in the infrastructure and agriculture sector, having a 45% and 32% respectively. Despite the rise in the use of this application in this technology in the civilian sector, we have seen no uniformity in terms of flight and other requirements. And therefore, this study attempted to develop a framework that can be adopted at all times for data acquisition on infrastructure projects using unmanned aerial vehicles. The methods and materials, the study basically focused on a review of several papers, peer-reviewed papers and conference studies on the use of this technology in the different application areas. Both program script, automatic program script and manual screening was adopted in the review. The automatic program script program application used here being mainly the Google Scholar application. The automatic program script was used to search for key terms such as UAVs, fixed wing, drone, and quadcopter, basically to find more about what this technology is. The search was finally narrowed down to the area of interest, with the area of interest being infrastructure. The search was narrowed down by typing key terms such as the use of UAV in infrastructure, UAV and infrastructure. Upon gathering enough documents on the use of this application, this technology in the various applications. Manual screening was carried out. This was basically done by reading through sections of the obtained documents and the abstracts to identify which documents are relevant for the study and reject those that are not relevant. And during this review, comparative analysis of the use of this technology, that is the contrasting and similar elements in regard to the use of this technology in the various sectors was looked at. Key emphasis was put on the workflow and the guiding principles when using this technology. That is right from the preparation, planning, implementing the mission, and processing the data. From the above, a framework was developed, divided into 4 stages. The first being reconnaissance, data acquisition, image processing, and use of the products for rapidly assessing property value. Under each of those stages, key tasks were looked at, as you will see in the framework. This is the proposed framework, divided into 3. We have the first, just like any other mapping project, the first being reconnaissance. I've spent much of the time here, as the discussions, subsequent discussions, is all about this. Under reconnaissance, we have first is to conduct site preparations. Under site preparation, there's need to check the site where you're going to fly for obstructions. Obstructions can be electric power lines, they can be tall buildings, they can as well be trees. So you need to scan the area around for such obstructions. Secondly, you need to check the weather suitability by checking weather forecast data. How is the weather? You know, these aircrafts are affected by harsh weather. They are unlike the ordinary, the bigger aircrafts that can withstand bad weather. Then you also need to get a good knowledge of your area of study, where you intend to fly. How big is it? Then the second, under reconnaissance, is there's need to look at the flight parameters. Key among the parameters is the ground sample distance. That is the resolution you intend to acquire your data at. The lower it is, the better. Secondly, there's need to look at the camera, sensor information. Look the focal length of your camera, the sensor width. You need to look at that. Then also you need to, under flight parameters, there's need to identify a better or a suitable place to take off and also land. It is advisable, preferable to have a takeoff at a higher point in your area of interest. The takeoff can be a relatively flat place. You can as well have improvised, create a pad as your takeoff and landing. Then the third area under reconnaissance is the available devices. What type of device are you going to use? UAV platforms are basically characterized into 2. We have the fixed wing. We also have the multi-rotor. And the selection of the suitable platform basically is dependent on the application. But key aspects one can consider when selecting the aircraft is, 1, the endurance. How long is your work going to take? The fixed wing have certain endurance, that are the longer endurance, unlike the multi-rotor that have certain endurance. You look at the weight of the aircraft. You can also look at the sensor capability, the sensor that it carries. Then under the available devices, there's also need to look at your ground control station. This is where you will monitor telemetry information about the flight, telemetry data, the flight speed, the battery level. So there's need to look at that. Then we have the legal parameter. We have the legal parameter. As I said, this sector previously was under the military. We have a lot of legal requirements must go undertake to fly one. One is you need to check for airspace restrictions. There are places you're not supposed to fly around, like the airport, military zones. Such areas are not allowed to be flown unless you seek for permission. There's need to obtain authority to fly over the site where you're going to fly. The individuals, you need to notify them. As the operator of the aircraft, you must be a licensed operator. And then there's also the maximum flying altitude. As per Uganda's regulations of last year, the maximum flight altitude is about 400 feet for civilian applications. Then we also need the base data to improve on the processing accuracy. That is our ground control points established, measured using the traditional ground measurement techniques. Then under reconnaissance, we still have the flight plan. These are ordered list of items that the drone must follow as it implements the mission. We have the overlap, the forward and the side overlap, the flight altitude, the flight pattern, sensor payload status, and weather requirements. Having done that, one can now do the data acquisition. Before you do the data acquisition, you need to undertake flight checks and setups. Assemble your UAV, calibrate it to have a better performance, then conduct the pre-flight checks and launch your flight. By uploading the flight mission, taking off, using either of the two modes for civilian applications, the visual line of sight is recommended. Beyond visual line of sight is normally not recommended for civilian applications unless requested for. Then thereafter, you need to constantly monitor these aircraft. There must be an observer constantly monitoring the aircraft where it is. Then you land and you have your data. You then download these images from the database and select. Now the selection must be informed by a set criteria, and this criteria mainly is based on the flight plan. Selection can be manually done or automated. However, manual has its challenge. Manual can only be applicable when you have less number of images. Where you have thousands, then the automatic selection is advised. Then processing the images, starting from the processing follows the image alignment, point cloud classification, georeferencing, and then performance of the bundle block adjustment. Basically, under the feature point image matching, what happens is the images are geometrical aligned. Just a few minutes. The images are geometrical aligned based on the key points, the common points on stereo pairs. And in the alignment, the interior and external camera parameters are used together with the ground control points to come up with what we call a sparse point cloud. Now, this sparse point cloud can then further be densified using a technique referred to as the epipolar geometry to have what is referred to as the dense point cloud. Then from your dense point cloud, you can generate a 3D texture, or what is referred to as the mesh, where you have vertices, the edges and faces of the object of interest. The accuracy of these products can be assessed based on the root mean square error technique. That is comparing the XY values from the DSM to the observed points that are from the base data, the checkpoints. The lower the root mean square error, the better it is. Finally, the property values can rapidly be assessed by incorporating in the strip map where you have the right-of-way details and the digital cadastral map where you have details of the plots to ascertain the value of the plot. Then the models, the 3D objects obtained from the processing can be used to rapidly assess the the value of the property that is affected. Validation is then done by comparing the results from this technique from the current or the traditional technique of property value assessment. This basically was what I was explaining to you. These are the obstacles, rather the obstacles one must look at when for your preliminary survey. Scan for them, the flight parameters I was talking about, the available devices, the rotor wing and the fixed wing. Down there's the control station where you do observation of the telemetry data from. Then the legal parameters, airspace restriction, notification of stakeholders, the base data, the ground control points. You can see observation taking place there of the ground control points. Then the flight plan with its specifics on the right there. We are doing the data acquisition. You can see the project team assembling the fixed wing Quest UAV. On the right, a multi-rotor UAV assembled, ready for takeoff. These are the calibration, what you undertake under the calibration. Launching the flight, the two modes, one can use visual line of sight and beyond visual line of sight. See observers there, observing where the aircraft is heading. Then make constant maintenance of the radio link, that is between the ground control station and the UAV. Then this explains the processing, which I've already explained. As I said, processing takes place in cloud or using high power computers. These are some of the recommended systems requirements of the computer one can use to process the data. You can see for small projects under 100 images, you need a RAM of at least 8 GB. So the data really needs a supercomputer. That's the formula that is used for assessing the accuracy. And here on your right, we have a right of way from the strip map and the digital cadastral map. From there, you can easily calculate and identify the affected portion that is within the infrastructure corridor. And in conclusion, this is what I'll say. The suggested framework considered both the legal and technical requirements for operating a UAV. The framework is split into 4 phases: the preliminary survey, data acquisition, image processing, and using them for rapid property value assessment. And it further covers key aspects regarding the use, and therefore can be adopted for other UAV applications. Thank you.
For your presentation, I'll now invite questions regarding this. Are there any questions from the audience? Okay, I can see there.
I have a question. 2 questions actually. They're quite consequential. The first one, you talked about reconnaissance. So I'd like to inquire, is that ground reconnaissance where you have to go on ground, or there is another way of doing it? And then the second question is in relation to that. So if it's ground, doesn't that sort of beat the purpose of using drones? Because one of the driving forces for using drones is that you're trying to avoid the exposure, say, of, let's say, a remote place for people having to go to those specific places. So is there maybe another way you do the reconnaissance, or you have to go there on ground? Thank you.
Thank you for that wonderful question. The reconnaissance is done on ground. As you are aware, drones are lightweight aircrafts. And when they are taking off, they must take off from the ground. So there is need to go on ground to identify a suitable platform where you can and land from. So the reconnaissance I'm talking about here is done on ground. It's not done anywhere else. Does that answer your question?
Perhaps we are not, my question was about the area the drone is surveying. There's no ground reconnaissance done for that?
It is done. That is why when you go to the framework, under site preparation, the last there is the area of interest. The area of interest. So there is need to go in your area of interest where you intend to fly and carry out, get better understanding, knowledge of this area where you're going to fly.
So what happens if the area poses hazards to people?
I can give you an example in one of the scenarios as we were conducting our data acquisition. We had to take off on top of a storage building because the area was crowded. And for a fixed wing, if you are to use a fixed wing, you need a larger space for takeoff. In a built-up area, there are no such places. So what we did, we had to go up on top of a building to take off our UAV.
Okay, Charles is going to be with us during lunch. You can sit near him and derive a better understanding of drones. I'll now ask us to go for lunch. I think it should be between 15 to 30 minutes. And we'll be back here at probably 2:15 for the last session of the conference. Thank you very much.